misconceptions. We've got truth in our possession. No room for doubt, no time to waste. It's time to put flat Earth in its place.
Welcome everybody to Tuesday night. It's a Thursday. It's late. I'm your host, MC Toon. I will be reviewing a debate tonight between Lucas, who goes by Sealion Prime, and Peter, the Globe Gangster or the Globe Prover. They're going to debate against, I'm just reviewing this, they did debate against Alan from Space Audits and Shame St. Plagiaire. He's got that little update to his name for a purpose. It was hosted by Jaren a couple last week, I think. And Jaren does a good job hosting, one of the best hosts around, even though he thinks the Earth is a space pizza. Not in space, that's sarcasm. So he does a good job moderating. Anyway, that's the whole point. He keeps them on task, keeps them focused. So, but before we start that, I think you might need a little background information. So I'll give you a little refresher if you know it already, and a little background if you don't. Around the time of Newton, Isaac Newton, in the 1600s, light was thought to be little corpuscles. They called it the emission theory of light. It was corpuscles of energy is what they thought it was. And Newton himself and quite a few others. But by the early 1800s, they started to say, wait a second, it seems like it's a wave. It has properties of a wave. Maybe it's a wave. And so they were hypothesizing, pondering whether or not light was a wave, and that it was just an interruption of that wave or a modification of the underlying foundational medium of something, and that the light was moving through it like waves across the surface of a pond, or like sound waves that travel through the air. That the air doesn't move from the mouth to the microphone or to your ear. The wave does by pressure modifications, and so they thought that light moved like a wave by somehow modifying the foundational medium. They called this the undulating theory of light, or luminiferous ether. By the late 1800s, though, a whole bunch of holes were starting to be found in this. Things were not working out how they thought. Things didn't work right. So they were wondering maybe there was a problem. Now, back up again to the 1700s, late 1600s, early 1700s. People were starting to figure out how the Earth moved around the sun, like how fast it did, and the distances and things like that people were working on. So Ole Romer was one of the early people to figure out a little bit of a mystery. And he did that by having extremely precise timings of when Jupiter's moon, I think Io, went into the shadow of Jupiter. And through different times of the year, they knew very precisely when that would happen. And he discovered, when he was measuring it, that it was, I think, on the order of 8 minutes late, 8 to 10 minutes late. It's like, that seems very strange. Well, it figured out that it was because at one point in Earth's orbit around the sun, it was closer to Jupiter. And then when Ole Romer measured it, it was farther away from Jupiter, from Earth to Jupiter. So the light took longer to get from Jupiter to Earth. So the eclipsing or the occultation of the moon was delayed by that time. So that told a lot of information about the light has a finite speed, and about the movement of the Earth around the sun and within the solar system. Then you jump forward to 1700s, and they were theorizing that parallax that when we're in different points of the orbit, one side versus the other side, the near stars and the far stars would have a slight different movement. The very far stars would appear to not move at all. They do a tiny bit, but so far away that it was too small. And that the near ones, you would be able to see, it has a little shift in relation to the distant stars. So James Bradley sought out to measure that difference, and he set up a telescope that was pointing very nearly straight up. So he I think it was Gamma. Was it Gamma? I'm not gonna say the name of the star. I'll get it wrong. Anyway, it was a star that was rather mostly up for him as he was in England, and he didn't measure parallax. He thought he was going to, but he didn't. What he did measure was that the stars have a slight oval throughout the year. It took a whole year and it traced out a slight oval. Their measuring apparatus was accurate to about 1 arc second, and the size of that oval was about 20 arc seconds wide, so well within the precision of the apparatus. He figured out later that this was due to a composition of the velocity of light and the velocity of the Earth around the sun. And that when you look to stars in the north or south celestial poles, right, due north of the ecliptic, the plane that the Earth travels around, those stars trace a circle, and the stars on the plane of the ecliptic, the equator of the celestial sphere, they didn't trace a circle, they traced a line, and everywhere in between they traced an ellipse. This was confirmation of the Earth moving around the sun, and was also tied to the speed we're moving and the speed of light. All of these things were partially figured out in that, and in more detail they were figured out. Further, in the late 1800s, Vogel and Schneier in Germany measured something very interesting. They discovered that when in our orbit around the sun, as we're moving toward stars, right? Because we're moving, right? So we're moving toward stars. When we're moving toward those stars, the color of the light shifted a tiny bit, but enough for them to measure. It was a slight blue color compared to when we were halfway, right? So when we're moving toward them, then you get to halfway, we're just moving horizontally now. We're not moving toward or away from them, right? Then later, 3 months later again, we're moving away from the stars. There's a slight redshift. So annually there's a blue shift, redshift of all the stars in the plane, in the ecliptic, right? The plane, the equator of the celestial sphere around which the Earth orbits the sun. But due north, due south, they didn't have that. Those two things in three, Ole Romer, James Bradley, Vogel and Schneier, those three particular things, amongst other, were extremely strong knowledge that the Earth orbits the sun. So now Vogel and Schneier was slightly after some of these important measurements that you will hear about later, but it's important to know that that's absolute confirmation of the movement of the Earth around the sun. So now, the foundational medium called the luminiferous ether is a very specific thing. It is about light and light's propagation as it moves along. Then there is also the undulating theory of light. Remember, luminiferous ether, undulating theory of light, same thing, right? That's all that it talked about. It didn't talk about having any particular impact on physical objects. It didn't talk about having any ability to generate electromagnetic fields. It didn't cause any physical forces on objects. It didn't do any of those things. The luminiferous ether was just a transport for light. The idea of it was. So when people talk about the ether, though, that's typically what they mean. That particular definition of ether. But there's more than that. You can define ether to just be the foundational medium in which the entire universe, all of reality sits. And so that's a different definition of it. It's a very, very broad definition of it. And it has particular properties based on the definition you're using and trying to figure out what it is. So sometimes people try to deceive by putting in the word ether as spoken about in kind of a broader sense as the foundational medium in which the entire universe exists for luminiferous ether. So that is a common thing that people that don't like relativity try to swap in. It's a bait and switch. It's a very dishonest thing. That's not what happens, at least in the portion of this debate that I've watched so far. But it's a very important thing for you to realize as Lucas and Peter start to do their presentation. I have to say, it is absolutely fantastic. The angle they took on this is genius. It's brilliant. So I will play with very little interruption, hopefully, their introduction to it before I have much more to say on the topic. I have this. So this was on Jaren's channel. I have over here. I have right here my live stream. That's you guys, and then down below that is the Jaren's live stream. So I hope you can watch some of the nuttery that happens as they're talking. I don't know how fast it'll go. Hopefully it's not too fast. So anyway, that's the introduction. I hope it was good. I already got a little feedback from Lisa that said it was good. So thank you. I'm glad you liked it. I hope it. And then I hope that if anybody who knows better than me, plenty of you out there, if there's anything that I got wrong or you want to comment on, feel free to do it in the comments of this video, or better yet, right, do it there. Definitely do it there. Send me a direct message if there's something, because I won't necessarily be able to read it in the comments under this message, though I'd love if you did it there, because YouTube likes that. But definitely do reach out to me if you think that I got some of that wrong, or any of the rest that I'm covering here. So, and I do hope that, let's see, Sealion Prime, are you in the chat here? And Lucas, that's Lucas. Peter, I don't know what your name is here, but if you're here, let me know. Just say that you're Peter. And all right, here we go.
Sealion Prime, and they are all here. Let's check in with them. Say hello to the guys. We've got first up. Let's say hello to Peter. Peter, welcome to the show.
I'm gonna jump ahead to their presentation.
We represent globe gangsters, but today we'll try to build some bridges with our ether cosmology community. So I will present our position. All right. Our position is that the true ether cosmology was established by the famous experiments of the late 19th century, which led to its current description via the general theory of relativity. That's our position, and we will defend it all the way. The true nature of ether since 1920s is ether is a metaphysical background that acts as a medium or substrate for matter and electromagnetic phenomena. It is a four-dimensional substrate whose states cannot be ordered by time alone. We cannot observe simultaneous states at different locations in the ether. Its structure is influenced by the presence of matter, and radiation, and movement of matter and radiation occurs within or over ether, and it's affected by its local shape. A renowned 21st century ether cosmologist summarized this as follows. Ether is an immaterial background medium of pure potential. It cannot be quantified or measured intrinsically. What we know about ether when no matter is present or locally is that it has these properties shown on the screen. When we observe ether behavior, we conclude that relative motion is rotation of ether. For all observers, ether rotates, and they all observe time dilation and length contraction in the relatively moving frame. The objects themselves do not shrink in any of the frames. It's the function of the ether rotation that causes the perceived length contraction and time dilation. We do observe this in nature.
Okay, just for clarity, it might have been a little confusing. They are using, this is what I said was absolutely brilliant. They are using the word ether as the foundational medium of the entire universe. They use the word ether over and over and over. These are not the derpers. These are the smart guys, okay? Right? But because, and he quoted from Einstein, right? Let me right there.
Via the general.
Right, hold on. I'm trying to get it here. There you go. Metaphysical background acts as a medium substrate for matter, four-dimensional. Four-dimensional substrate is your key. That's relativity. General relativity is four-dimensional. All right. And then a renowned 21st century ether cosmologist summarized it as follows. Who is that? Who is that renowned 21st century ether cosmologist? Brilliant. It's Einstein.
It's affected by its local shades. A renowned 21st century ether cosmologist
Calling him an ether cosmologist is genius.
summarized this as follows. Ether is an immaterial background medium of pure potential. It cannot be quantified or measured intrinsically. What we know about ether when no matter is present or locally is that it has these properties.
Okay. That's relativity. That's general relativity right there. That matrix.
Shown on the screen. When we observe ether behavior, we conclude that relative motion is rotation of ether. For all observers, ether rotates, and they all observe time dilation and length contraction in the relatively moving frame. The objects themselves do not shrink in any of the frames. It's the function of the ether rotation that causes the perceived length contraction and time dilation. We do observe this in nature. For example, a lot of muons get produced in the
and look at, let's see. Oh, it was a bit ago. All right, Whitsitt was in there. He goes to somebody else. So you disagree with Einstein and the mainstream model, but that's cool with me. Whitsitt likes to take and twist things. It's his special skill into thinking that Einstein agreed with the luminiferous ether. He did not.
Sphere, around 1 million of them, let's say, per area. We observe 49,000 of them reaching the Earth. This is impossible due to the extremely short lifetime of a muon. The only way we can explain it by explaining it via time dilation and length contraction. Here's the result of such a measurement, where we observe 49,000 muons out of 1 million reaching the ground. From the point of view of a muon, what happens here is that the length, the distance, shortens from 10 to 2 kilometers. But from a point of view of the observer on the Earth, it is the time as perceived at the moving muon that lengthens. This is the only explanation of that observable phenomenon in nature.
Okay, so he went over that rather quickly. I'll explain. I'll expand a little bit on it. Muons are created in the upper atmosphere when cosmic rays interact with other particles in the upper atmosphere. Muons have a very short lifetime before they decay. They have a half-life. So things with a half-life means that if you have 1 million of them, then after the end of that half-life, you'll have 500,000 of them. And so you can measure then, the way you do that is you say, well, here's a time, and here we got 1 million of them, and here's a time later, and we got 500,000 of them. Oh, well, that amount of time, that's a half-life, right? So the length, the half-life of a muon is known before this test. So they're at the top of a mountain, and they measure the number of muons that they're receiving at the top of the mountain. Then at the bottom of the mountain, they measure the number of muons at the bottom of the mountain. Now, the number of muons emanating are consistent. But since it's a lower number, we know for certain that they're coming from higher up, right? They didn't come from down below and then somehow magnify how many there are. They have to, right, come down. So if you do not include relativity, then it's not possible to receive the number of muons down low that they did receive down low, because their half-life would have expired multiple times, right? So there would be still potentially some, but very, very few compared to how many they measured. Not the right numbers. So relativity is the answer for that, because in relation to the reference frame of the Earth, the muons are moving at a very high percentage of the speed of light. So time dilation, length contraction, those things, they're related, happen. And so the amount of, I need to make it clear, I don't know if I did enough. The amount of time from the top of the mountain to the bottom of the mountain, there would not be enough muons. Their half-life is too short for many muons to get to the bottom. But many muons do get to the bottom. So if they are moving at a significant speed of light, the relativity predicts that they must experience some time dilation. So they will last longer from our frame of reference, so that there are more down lower. They last longer because of time dilation. All right, do you get that? Why are we talking about muons? We're talking about muons. It's muons.
When matter is present, ether is described as follows. On the left, we see the distribution, the shape of the ether, which influences the motion of matter and radiation.
Now, he keeps calling it the ether. I love it. This is Einstein's field equation.
On the right, we see the distribution of matter in a given location. This is what we know about ether today. This can be easily measured, even by amateurs. This dad left a few atomic clocks at home, synchronized them with a few more atomic clocks, and took them on a mountain. Because he was in a different location of ether, those clocks ran differently, and he was able to measure them. In laboratory settings, we can measure time dilation, the difference in elapsed time, between atomic clocks at distances as short as 1 meter or 3 feet. Light propagation is also distorted by local shape of ether. On the left, you see an observed galaxy, the blue ring, and the light originating from that galaxy is deformed by the ether's shape surrounding the yellow glowing object. On the right, you see a chart showing how many papers confirming this effect in astronomy have been published in recent years.
Okay, I need to correct something. It wasn't Einstein that said that, it was Whitsitt that said that, but let me, I thought he was quoting Einstein. So I don't know where Whitsitt got that from, if he wrote it himself, but I didn't think that he did. So I asked Luke. Lucas just sent me a message saying no, it was Whitsitt that said that. So anyway, that's I don't think that Whitsitt wrote that himself. It was from Flatoberfest 2 years ago. So apologies for getting that wrong on who said it, but it was interesting. It was a good way of saying it. Anyway, Whitsitt just says, yikes, Shane and Alan about to eat. Well, Shane's definitely going to eat. I mean, he's probably eating right now. Not Shane, I'm sorry. Shame St. Plagiaire. I need to get his name right.
Furthermore, we know that ether can wave itself as a medium. When dramatic cosmic events occur, they can affect the shape of the ether, and that disruption propagates through space. We have devices such as LIGO that have successfully measured such waves in ether many times. I conclude by saying that general relativity is an empirically verified description of the true ether cosmology. And I yield the remainder of my time to my good friend Sealion Prime.
All right, Sealion, go ahead. You got 5 minutes and 5 seconds.
Peter, you'll need to stop sharing so that I can share. Okay, go. Okay.
Carol,
Are you able to see my screen?
Yep.
Excellent. So I will be building off of the affirmative statement that Peter has made, that the theory of general relativity as it stands and its encapsulation of special relativity fully is describable within this notion of ether. We will then build off of the specific experiments in the late 19th century and early 20th century that confirm that effect, and discuss the role of those experiments in furthering our understanding of the ether as it exists.
So yeah, Lewin basically they just swapped space-time for ether, which Einstein in one of his later talks had equated in some sort of a quote, not any sort of like rigid paper or description or mathematical equivalence or anything. He just kind of said, yeah, it's kind of like space-time is ether, something like that. I don't know the exact quote, but yeah, they just swapped space-time for ether. Just listen to this. I love how they did it.
What's beautiful about this topic is that we often get to see in physics this phenomenon of the macro scale translating to the micro scale. And what you're seeing here from a video from Veritaserum is an illustration of a wave interference pattern of constructive and destructive interference. That pattern is created by any sort of mass waves or light waves, which are propagating, and leads to the ability to perform interferometric studies on things like phase shift. The first sort of experiments that we had related to this notion of the ether came in the mid to late 19th century. Earlier than that, we had the theory of Fresnel, which described some of the properties of what he thought might be a situation of an ether. The theories of Newton, which established this idea of what an ether might be. But all of these sort of had the idea that ether would have to be absolute in some sense relative to the Earth. Airy's experiment was very interesting because it provided a direct measurement, as shown on the left with a normal telescope versus a water-filled telescope. And through an inability to measure an expected deflection, demonstrated for the first time that there might not be that absolute frame of ether that we were looking for. Now, this was the basis in later experiments for the beautiful device of Michelson and Morley. This is one of the greatest experiments ever conducted in the history of physics, where a block was suspended on an annular ring of mercury. The interferometric pattern would then be entrained through the ether if it formed a medium that was absolute and stationary relative to the Earth, and that ability to measure the resulting effect on the interferometry, those wave patterns that we talked about, would then form a test of whether that absolute frame existed. Now, what did we find in this experiment? As was confirmed many times in later experiments, particularly in 1926 with a different interferometer at a smaller scale, that absolute nature of the ether as we thought of it was not what we observed. So how did this influence Einstein? Well, you may have heard this classic quote, "While I was thinking of this problem in my student years, I came to know the strange result of Michelson's experiment. Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect. If we admit Michelson's null result as a fact, this was the first path that led me to the special theory of relativity, among other things." And I thank our Aether cosmology friends for bringing this beautiful quote of Einstein to our attention. Now, refinements to the theory wanted to test essentially what were the other kind of things we could detect about the ether. And Sagnac, in particular, had a sort of different interpretation of the ether relative to Einstein. But he had this idea of a rotating loop interferometer and wanted to test if by rotating it through an assumed stationary ether medium, you would observe a phase shift in the light. And indeed, that phase shift was observed. However, what has been confirmed countless times since then and shortly thereafter was that such an effect was entirely explainable within the framework of special relativity and actually provides strong evidence for the isotropic nature of light. At the summit of Mount Wilson, Dayton Miller provided further evidence for the nature of the ether, measuring very precisely the unexpected Aether drift, which would be sort of altitude and location dependent. Now, initially, this was very difficult to explain. However, as we'll show later on in open discussion, and we can provide papers to this effect, we now know in a relativistic sense how we can describe the ether on the basis of this experiment. And then we come to sort of the last great classical interferometer, I call it, which is the work of Michelson, Gale, and Pearson. And this was, again, a measurement of the assumption of a stationary ether relative to the Earth's rotation. Again, anytime we would entrain the light through a stationary ether, the expectation under the theory of Fresnel was that there would be a resultant drag affecting a phase shift. This basically allowed us to confirm that no such stationary ether exists, and also provided extremely strong evidence for the theory of relativity as it exists. Now, Einstein wasn't divorced from all of these experiments, and in a letter to Lorentz, he famously stated this equation, and this relates directly to our characterization of ether in the prior construction, that the structure of the... Okay, yeah, we'll stop there.
Okay. Whoever's going first, Alan or Shane, you have 5 minutes.
I got it. Yep, but we don't think we need to screen share or anything, so we'll be fine. We're just going to speak, I think.
Okay.
All right, so now you got that. I gave you a little bit as they went through that. Great job. Love what you did there. I want you to know a couple things about Shane and Alan. Neither of them can touch math. They can probably just barely, take an equation and move a variable to the other side. It's probably about the extent of their algebra abilities. They definitely can't handle much more beyond that. None of them have done any hands-on experiments. None of them have hypothesized anything. None of them have done had any of their ideas tested, right? And I'm not saying you have to. I'm saying something else. But none of them have done any of these things. The typical things that scientists do, also, they can't do the things that scientists do when they're reviewing other scientists' work. Understand it at a good level. They can't handle the math, right? And it's a high level of math, very high level of math. So I'm not saying that a lot of people can. You don't have to in order to have a conversation on this. But if you're going to say that the people that do understand the math, the people that do the work, the people that do experiments, the people that put their reputation up on the line when they're writing a grant, when they're publishing a paper, when they're presenting at a conference, those people, they do understand the foundational stuff going on. Right. So when this guy is critiquing the people that actually, don't just get their feet wet, right? They're in the ocean. They're deep in it. He doesn't do anything. He's not an armchair quarterback. He's not the Sunday morning quarterback. He didn't even get out of bed. Okay? Just keep that in mind as you hear him talk.
So.
Oh, no. I clicked the wrong thing. All right. I know where he started. That's right when he started.
Our components have combined space-time and relativity into their wonderful position as ether cosmologists. We welcome them. But only those who don't understand relativity actually believe in it in any capacity, only by surrendering.
Only those people that don't understand it believe in it. It's his opening statement. He doesn't understand it. Very important. He does not understand it. He's not got his feet wet. He's not done any experiments. He can't handle even scratch the math. He can't do any of that stuff. And he's accusing the people whose career is to understand this. The thousands of people that really do understand this topic. He's saying that they don't understand it and this idiot does. Shame Saint Plagiaire thinks that he understands it. Right? His ego is as giant as his body.
Your understanding to other men, can you actually stand upon the pit of sand and pretend it to be a solid foundation? And in the words of Nikola Tesla, right, and when he described relativity, he said,
Now, Nikola Tesla, great engineer, horrible physicist. Now, listen for what. Shane is mostly about quotes, right? He got it from Witsit. A quote isn't an experiment. And so quoting somebody that didn't get their feet wet on the topic, like Tesla, who didn't get his feet wet on the topic. Tesla didn't do the math. He that wasn't his thing. So all of the things that he's about to quote from Tesla are useless because it's not evidence, it's not experiment, it's not anything.
Einstein's relativity work is a magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar clothed in purple whom ignorant people take for a king. Its exponents are brilliant men, but they are metaphysicists rather than scientists, right? So it's relativity theory has been around for over a century, and to this day, the acolytes in support of the theory have actually surrendered their faculties to equations and concepts that even they don't fully understand or even care to understand in most cases. The people depend on the understanding of others with a severe appeal to majority and to authority so completely that it's almost a form of surrender. Those who don't understand it actually cannot see how absurd it is. The classical proofs of relativity are often cited to hand-wave dismiss any criticisms, but each one of those gets actually destroyed when you look into the details. We'll address many of those tonight. Another quote from our boy Thomas Dennis says, "It's impossible to teach special relativity without deceiving the student." That's from Science and Philosophy 10, number 2, 2022, pages 146 to 67.
Now notice, so far, no experiments, no evidence, no analysis, nothing. Quotes. That's all he has.
And when you get down to the so-called proofs, right, including the perihelion precession of Mercury, the gravitational redshift, the alleged detection of gravitational waves at LIGO through embedded and nested neural network.
All right, so he talked about LIGO and then an embedded something neural network. Listen to the next words.
Neural network and noise data, which gets elevated through a series of filters, which actually get designed to produce the data they're looking for.
Designed to get the data they're looking for. The problem is, how is it designed to get the data they're looking for? Like he's suggesting that it's being manufactured. How is it being manufactured when there's external references that support it? Right? It's this is the important thing. LIGO measures things independent of other measurements. Right? These other measurements are not the same at all, but they correspond in time to measurements that happen at LIGO. How could that be? How could it be manufactured data if something else completely external to LIGO also measured it? A different part of that event at a different time, not at the same instant in time either, because they're measuring different phenomena, photons versus gravitational waves. Max is sending me some papers on Discord. Anyway, has he looked at and analyzed the data that LIGO published? There's hundreds, maybe thousands of papers from LIGO. And he just one sentence said, oh, it's just noise that the AI was designed to just pick up on and apparently invent.
Actually nothing more than mathematical tricks and misrepresentations of data. Right? In all cases, the predictions are actually post-dictions, disguised as predictions, straight up copied, or completely fraudulent. When you get to the concept of space-time as a physical entity, it's purely imaginary. It cannot possibly have physical qualities. To apply physical qualities to a concept is reification, severely lacks any experimental proof or any sort of backing in science or empiricism.
So he did mention the actual empirical measurements and hand waved them, right? LIGO, redshift of gravitational redshift. And the perihelion of Mercury, right? There's others too.
symmetric tensors and 4-dimensional coordinates doesn't actually change that. It just makes it a mathematical trick, even though the speed of light is constant, right? Which is a primary postulate of special relativity. It's shown basic experiments in ECEI and ECF that this is not the case. And just to wrap it up here, we'll contend that relativity has inverted our understanding of the universe, leading to absurd claims about cosmic distances, timescales, and unprovable measurements and frames of reality that will never exist, that no one can ever verify. I advocate that we return to experiment-driven empiricism, and we can...
Experiment-driven empiricism. Oh, dear. Let me read this. Sealion Prime says, drink every time Shane contributes to the debate. And this is for the Mormons in the audience. If you don't know, Mormons can't drink, so they're safe.
Fully deal with what we can see and deal with and measure, and the lab frame is where all experiments take place, where all measurements exist, the only place where you can take measurements. And I cede my time to Alan.
All righty, Alan, whenever you want to start, it's all yours.
Thank you. You see that?
We do.
All right, cool. In the Aether framework, space and time are absolute. All measurements of velocity with respect to the speed of light are measured as c plus or minus v and can be answered in the first order as a ratio of v over c, or at a higher order without invoking the gamma factor for space-time symmetry.
Gamma factor, I think he's talking about is Lorentz, the Lorentz contraction formula.
Relativity theory makes use of covariance to satisfy linear orthogonal transformations to support the principle of the constancy of C. In this manner, a geometrically convenient position is invoked to facilitate a stationary frame relative to some observer moving at a constant velocity. By using covariance, the x-axis and time axis will be changed as a function of the moving observer's velocity squared over c squared. This is called link contraction and time dilation. These effects have no explanatory power over absolute measurements of velocity made by interferometric experiment. In order for link contraction and time dilation to be true, you must first assume an unmeasured velocity to be the cause of the produced second-order effects, which render the observer's ability to measure his velocity using light impossible in his own frame. Absolute time and space can be demonstrated with GPS and interferometry. Here we have Carol Alley in 1979 proclaiming that relativity exists in GPS, and then 17 years later in a GPS overview, he's begging for it to be implemented specifically.
Now, notice this. He's not the couple things that he mentions here. This is not in support of Aether. This is an attempt to discredit the other side. And I don't think he quite has the depth on this.
Relativity of simultaneity and the associated Lorentz transformations. In 2000, we have Neil Ashby confirming that GPS uses a Galilean synced time frame for the ECI and ECEF frame, which is linked to the stars. Events will always occur simultaneously in the ether, regardless of the state of motion for the observers. But most importantly, this framework is based on an absolute fixed lab frame, and the ether will serve as the mechanism that facilitates Galilean velocity transformations in C. For predictions of the physical properties of the ether, they are as follows. There will be an anisotropic effect, a height effect, a space effect, and a hydroaerodynamic effect. The anisotropic effect is that there will be a preferred direction.
All right. He's going a little fast here. The velocity of electromagnetic waves propagation depends on radiation direction that is stipulated by the relative motion of the solar system and the ether, medium responsible. That's not what he just read. He talked about aerodynamic. All right, I'm not going to replay it.
Speed of light going east and west, and there won't be one going north and south. The height effect will be that there will be a vertical velocity gradient that increases that will increase the preferred direction bias as you increase in altitude. This is substantiated by Miller, Galev, and the Kennedy and Thorndike experiment. The space effect is that there will be a measured periodicity throughout the day and throughout the year that corresponds to the position of the stars and the sun. The hydroaerodynamic effect is that
hydroaerodynamic. So remember at the beginning I said that the luminiferous ether was a very specific thing. It was just about the transport of light. Right? Now he's saying hydrodynamic, whatever. This isn't about the transport of light.
The velocity of electromagnetic waves will be affected by the parameters directed by the directed system, i.e. the tubes and chambers of the interferometer. Conductors or dielectric insulators used as shielding will affect the turbulent and laminar flow of the ether wind in the same respect that it will.
Turbulent and laminar flow of the ether wind. Brilliant. So that they've it's a hypothesized that it's basically just like air moving, right? Like it's got a fluid, it's got viscosity, it's got, in interstitial friction between different elements of the ether wind, particles of ether. I don't. It is whatever they need it to be to solve the problem they're trying to solve, and also pretty much the majority of this stuff does not support flat Earth, which is their underlying purpose in all of this.
For any other gas or liquid that experiences flow through a tube. Relativity is based primarily on the principle of relativity of simultaneity. It states that two observers are given an arbitrarily agreed upon defined time for an arbitrary coordinate system, and then in that coordinate system, events that occur simultaneous in one frame will not occur simultaneously for the other frame. Based upon that principle of relativity of simultaneity, two postulates are put forward. Postulate one is that all inertial reference frames are equally valid. An inertial reference frame defined in relativity theory is a frame that's in uniform rectilinear motion at a constant velocity. In relativity theory, there is no preferred frame. Postulate two is the constancy of C is irrespective of the motion of the source or the observer in an inertial frame as defined by the first postulate. Consequences of these postulates leads to observers making measurements that are different for length and time based on the constancy of C relative to the square of their velocity over C squared. The physical mechanism of link contraction and time dilation is ambiguous with no clear explanation, i.e. lattice structure compression.
It has a very clear definition.
But the fact remains that in order for C to remain a constant in a moving frame, the moving observer must be physically contracted in his frame. Otherwise, C would measure relative to the observer's velocity and not the other way around. To falsify relativity theory will show that its postulates and principles do not hold true in the reality that it claims to have explanatory power over. Starting with the philosophy of relativity of simultaneity, and then in cases of electromagnetic propagation and processes making the wrong prediction for relative motion, it will show that the postulates are false. In the case of the unipolar dynamo paradox, the Sagnac effect in a uniformly rotating frame, and also the linear variant and GPS all require a preferred frame to make.
I like this one here. He's trying. 9LG says he's purely trying to sound impressive by using a bunch of smart words quickly and smoothly. It only works on those who understand who don't understand the subject matter. Yes. Look at the people in their chat there, right? These people don't understand the topic whatsoever, right? Alan and Shame don't either, right? None of those people understand it, right? Which of them have written a paper on the topic? Which of them have interacted with the people who do write papers on the topic and put forward some sort of a interaction with them to say, oh, well, here's something I hypothesized, and here's my analysis of it. Here's the computation of the consequences of my. No, none of that. They didn't do that. None of it. They're saying these things because they think it sounds good. They don't understand it. And definitely people in their chat are like, ooh, wow, that sounds smart. And yes, Witzit's post is complete irony.
Prediction. All motion is relative. Relative to what is the question? We'll show that a stationary lab frame makes the correct prediction every time in regards to electromagnetic processes. And the Sagnac effect has never once in the history of relativity ever been derived as a relativistic effect, which we will definitely be going over.
As far as I understand it, it's not a relativistic effect. So other than the constancy of the speed of light, right? That's the point of the Sagnac effect. And it's really not about general relativity. It's more about special relativity, being speed of light is constant.
That's the end of my time.
Okay, you're all set. Thank you much. All right, and you guys went first, so you guys can start up the conversation. We're going to set both clocks at 45 minutes. Is that what we decided? Yeah, I think so.
Okay. Let me I put off reading super chats and talking with you a little bit to get up to here. So let me read a couple things here. People were asking, is Shame St. Plagiaire the one who took Walter Bislin's model, stole it, removed Walter Bislin's copyright text from the source code of all of his files, and then put it up on his own website, claiming that it is his model, including removing Walter's description of it, saying that it is based 100% on the globe and then just projected to a flatness. Yes, he is the one that did all of those things. That's why the update to his name is Shame Saint Plagiaire. That is how he shall be called by me. He plagiarized Bislin's model. Right? He just lifted it and called it his own. And the point of Bislin's model was showing that when you calculate, he calculated it for the globe, like where stars are, where the sun is, where the moon is, and then projected it onto a dirt pizza. Right? And then like you see the line that the light needs to go through in order to get somewhere. So for example, when somebody's in Australia, in Sydney on December 21st, looking at the sunrise due east. The other day I got the direction of the sunrise. I said it wrong. I wasn't confused, I just said it wrong. Looking for, there it is. All right. So here is, right, just for an example, right, here is Australia, here's Sydney, right there, right, put it right there, there's Sydney, right there, right, see that? It's not great, all right, and the sun is rising. Well, the sun on the day of the equinox on December 20th, solstice on December 21st, is around the Tropic of Capricorn, and so it rises. It's up for more than half the day there, so I'm just going to estimate that it's about there, right? So you've got the observer there in Sydney, and this is where the sun is according to Flat Earth. Now, that's not a great one. I don't want to draw on this one. I'm running low, and I need to print some more, but I don't have. Okay, there we go. I don't have access to it. The printer that I never use the printer at work. They've, since I have used it last, it's been swapped out, and I'm on a different subnet. I can't get to that printer anymore. I have to get a firewall rule put in, like whatever. I got work to do. So anyway, so here they are in Sydney. This is the direction that they would need to look to see a straight line of sight to the sun, right? But in reality, when the sun rises from this direction, southeast, so the sun is here, and they look this direction to see it. So in order for that to happen, the light from the sun has to go like this, has to take this path. And so this one is a little better. You may remember this from the other time. Here's the sunset. And so if the sun is, what did I put right here? The sun is right here. The light that the path has to take has to go all the way around this way and curve it. And so Walter Bislin's model shows the light path curving like this, but there's no reason for it. This is ridiculous to think that this could be something that a reasonable person would ever think could be accepted. And in fact, no reasonable person does accept that. Only really dumb people accept that. People that don't understand that light isn't going to do that for no reason. And so that was the point of Walter Bislin's model. And Shame stole that, claimed it as his own, put all the source code on his website. It's in JavaScript, so you can lift it. You can't protect it. And then he's like, it just does that. Light just does that. Why does light do that, Shame? It just does. No, it doesn't, Shame. It doesn't just do that. That's not how it works. Anyway, that's why he's Shame St. Pierre. Kango44 says, Alan and Shame are just the biggest neckbeard clowns ever. They're embarrassingly embarrassingly amateurish fumbling around relativity, and a bomb on a train was just effing cringe. A bomb on a train. I don't know what the bomb on the train was. All right. Maybe we get to that later. Tim Davidson says, I'm just glad Pooh isn't here. Yeah, Tim doesn't ever want to be seen with Lord Illuminous Pooh. Melodic Lyric says, making Witsit admit to lying while continuing to lie on stream. $5 is a steal for that sort of entertainment. So I went back, got that, downloaded the video, pulled up the transcript from YouTube, found the spot. 5 hours, 19 minutes, 7 seconds is where you want to start to listen to Austin admit to lying. And you know what no truther has done yet? Called him out on his lies, because truthers don't care about the truth. Self-described truthers, actual people that actually care about the truth, would say, what the hell, what's it, you lied. That's not what we're about. I don't know if you belong in our truth club. But no, they didn't do that. Lord Illuminous Pooh says, say it to my face, Tim. Why is that getting likes? Tim and Lord Illuminous Pooh are going at it. Lord Illuminous Pooh again comes in and says, I have theories about emissions, but it's not light. Hey, you. It's almost like Lord Illuminous Pooh is someone else's childish alter ego. PhD Tony says, Alan is as ignorant as he is mendacious and a gigantic man-child. Tim Davidson says, correct me if I'm wrong, but the mathematics of the Big Bang point to the gravitational center of an object of unknown size. I do think that's the case. I have to say, I've never reviewed the mathematics of the Big Bang, though. Who here has? I don't know. My guess is it's probably not many other than, obviously, Clive Wells and PhD Tony. So, but it's worth a poll. Have you reviewed the math of the Big Bang? For reference, today I listened to an album named Big Bang by the band Magdalene. Love that. It's one of my favorites ever. Tim Davidson says it could be 1 billion light years across, maybe. It could be. Or 14 or 40. I think it's 40. CJ Lamro gifted 5 MC Tune memberships. Thank you very much, CJ. And then I think he just gifted another 5. So if you're on the receiving end, make sure you thank CJ Lamro. Kango44 for 10 Kiwi bucks. Says this is why particle accelerators are so cool. If you accelerate a particle to near the speed of light, smash them together, their decay is observable because their lifetime is longer due to time dilation. Yep, it's so cool. There's so many cool things about physics, and the people that deny it, they're just like they learn about it a little bit. They're like, nah, I'll replace it with Nutter Butter. Hang on, if you've been on the Nutter Butter TikTok page, you know what I'm talking about. Kango44 for 5 Kiwi bucks says shame is extra amusing. Not only is he incredibly stupid, he's obese too, like a stupid Jabba the Hutt. Now, normally I don't advocate, and somebody called me out earlier for fat shaming. Normally I would say, let's not do that. But two things. Shane really is an odious person. And yes, he is a fan of the Mustache Man. And number 2, I was there. I wasn't where Shane was, I'll say. But I was on the other end of there. And if you go back, you watch my videos from 2 years ago, you'd be like, oh yeah, that's different. So I don't know. Ashton Richards says, feel free to use any of my jokes. Did you? Oh, hold on. You have to send them to me. How do I have them, Ashton? All right, I mean, in here, I'm not going to be able to catch all of them that go through here while I'm watching and reviewing this. So if you send them to me, where we were talking earlier today, send them there. Kango44 says, is Alan really Witsit with a fake beard on? he says bro more. He actually says bro more. I didn't think it was possible. Sealion Prime says, why do people get banned from the Ether Boys server for asking questions about flat Earth? Easy. Because they have learned the fine art of protecting their echo chamber. You see, you can't have detractors in there because the detractors will stop the new people from getting lied to. Because anytime that somebody is, one of the Ether Boys are in there and they want to lie about stuff, they want to indoctrinate their new potential recruit. If other people are in there saying, no, that's not right. No, that's not right. Here's the actual stuff. That would get in the way of their evangelism. So they don't want that to happen. Detractors are not allowed. Icy Spin says, I'm learning so much. Go faster. I want to learn more. Sure. Lord Illuminous Pooh says, it's raining men and let the bodies hit the floor are just two sides of the same freak meteorological event. Oh my gosh, this is a good one, Kingo. There's that other CJ Lamoureux gift of 5 memberships. Sealion Prime for $5 says, after we realized it was ridiculous to have bendy light, shame now gaslights to claim that bendy light isn't required. And that I've seen him do that. When people are like, this is bendy light, he's like, nuh-uh, it's not bendy light. Well, what is it then? Well, it's fine. It's bendy. It's not bendy light. It's just not bendy light. Okay, can you explain it? Yeah, I can. It's not bendy light. That's it. No, but that looks like bendy light. No, it's not. Nope. Definitely not bendy light. That's not bendy light. Yeah, but that's light. It's leaving here and coming here, and in between it bent. So that makes it bendy light. No, that's in fact that's not that. Why would you call that bendy light? Anyway, yep, that's what he does. Shame. Slithery says boop. for €2, he says boop. And Kango44 says, I'm not advocating body shaming. I'm advocating Shane shaming. I mean, shame shaming. There you go. And all the shame. He deserves it all. All of the shame. All right. Go. So now this, so the way Jaren has this set up, when people talk, their timer ticks. And typically he has somebody else in the chat or in the call. I don't know if they did then, but typically has somebody in the call that's doing the metering of when they talk and don't talk. So you get 45 minutes, and at the end of your time, you're done talking. I like it because Vladdies like to pontificate, leaving a bit of a open time at the end. All right, here we go.
Mm-hmm. So set them both at 45, and they're ready to go when you are. We'll fix the screen here in a second, but that's good. So you guys go ahead, Lucas or Peter.
Nicholson Morley?
No, maybe let's start with something more fundamental than that. I think the main difference between our two views is you kept asserting the existence of an absolute reference frame and I think you called it an absolute lab frame. Could you tell us more about where that reference frame is located and where is the absolute lab frame?
Yeah, right here on Earth. Where all experiments
in which
are done.
location?
Well, how are you making a position if you don't know what a lab frame is, Peter?
one second. Right here on Earth, where all the laws of physics apply and were derived.
Okay. Are all locations on Earth equally the same absolute reference frame?
Do the laws of physics apply everywhere on Earth?
Yes, but is there an absolute reference frame if Sealion and I make a measurement of
You already
light?
answered the question. You already answered.
No, I
it.
haven't. I have
No.
not.
When I asked you where the laws of physics apply, and you said everywhere on Earth, that's the answer.
Yes. So it's relative within the Earth, yeah?
You were right to start at the basics, Peter.
So
let
if
me
I
ask
am
you a
moving
follow-up
away
question.
from you, one last question.
Yeah.
If I am moving away from you on Earth, am I seeing the velocity of light as constant, or is it slower for me, faster for you? How does that work?
Light will be measured relative to your velocity.
So it's relative. Okay, we agree.
Like
On
every
Earth,
other,
it's relative.
like every other wave.
So what is the reasoning behind the postulated constancy of C in inertial frames?
Well, that started by Voigt when he was trying to explain Dopplership with the postulate that the speed of light is constant for all inertial frames. He actually came up with the same derivation that that Lorentz used for his theory, and then that was used by Einstein. The equations are actually identical. I'll pull them up here in a second. So it comes from this lad.
That doesn't quite answer the question, though. What would
No,
be
one second. It answered it exactly, right? Because you said, "What's the basis for it?" Right? And it started right here with this guy Voigt on the principles of Doppler, where he was deriving the Doppler shift based on a constancy of C in all frames. This is the
I muted myself. You know why I muted myself? Because I refilled the udder mug. All right, what did I say? It was the best thing I've ever said. You're just going to have to imagine. And so the reciting of what I just said is just going to be a shadow of how awesome it was the thing that I just said. It was all about that you can't see on the original Jaren video. You can't see what Alan is showing here. It's just smudges on Jaren's video, and just because it's inset on my screen here, it doesn't change because Jaren's was at 720, mine is at 1080. So if you view that as this at 1080, this isn't really a whole lot different than the original broadcast resolution from Jaren. You can't read it. So Alan's like, this is from yo boy Voip. Whatever he said, I don't know. Wait. So, all right. There we go.
link contraction and time dilation equation.
So what is the consequences of the constancy of the speed of light for the Einstein-Maxwell equations? And why is that important?
That you will experience link contraction and time dilation if you're in the moving frame. And that time and space are not absolute.
So when we speak specifically to the extension of the Maxwell equations within the Einstein-Maxwell theory, what is the effect of the speed of light on the laws of electromagnetism within those equations? That's a simple question. What is the effect of the speed of light within that frame?
I don't understand the question.
Shane, do you understand the question? Okay, so if it were not...
That was good. I like that. Just condescending to them, as they should.
Not the case that light were isotropic, and we have two mechanisms to explain an anisotropy in light: a preferred direction and absolute frame, or relativity. Do you agree with that distinction? That those are the two primary ways that we could explain an anisotropic distribution. Okay. What would be the consequences if neither of those were true?
Oh, I got you. So Maxwell derived the speed of light based off magnetic.
I tried to unclick my click of
Where all
Max.
the laws of physics apply and were derived. He actually came up with the same derivation.
All right, hold on. Jeez.
Or relativity. Do you agree with that distinction? That those are the two primary ways that we could explain an anisotropic distribution. Okay. What would be the consequences if neither of those were true?
Oh, I got you. So Maxwell derived the speed of light based off of magnetic permeability and electric permittivity. And what he was doing, so that gives you the average speed of the speed of light in a vacuum, right? Now, experimentally, they measured that. And then when they get into more precise measurements with interferometry, they notice that the speed is slightly faster and slightly slower going with and against the east and west directions. That was used to measure quote unquote Earth rotation, but it's measured through the fluctuation of the minimum.
So oh my gosh. The east and west direction wasn't how they measured Earth rotation. It was the light going around the interferometer. I think when I debated Alan, he seemed to, I don't know, he seemed to not get this. And somebody mentioned, I've watched to about up to here on this debate. So most of this coming up is going to be new for me. But let me draw for you. All right, so interferometer is what I'm going to draw here. So you've got your light source here, right? And, we think of it as a laser, but it wasn't a laser until lasers were invented. They weren't invented at the time of Michelson-Morley and Michelson-Gale experiments. It didn't exist. So, all right. Then it goes through I'm just going to draw that. It's not right. It's not perfect, but anyway, it's just a mechanism to show that it splits the beam, right? So you've got a half silvered mirror, and there's a lot more mirrors that I'm not drawing, but then the light goes one direction and it goes the other direction, right? It goes all the way around. This is a very simplified version of it because they bounced the light back and forth many times. Or no, I'm sorry. In a Sagnac interferometer, it's got a area in the middle, and that's important. So this isn't the Michelson-Morley version of it. So, and then the light through a similar mechanism, then it gets recombined, and let's say it goes off to the side here. Both of them are now recombined, and then it's, put onto a screen of some sort, or somehow it's put onto a device so that you can measure it and see if it interacted. So when it's not moving, the light is moving in both directions at the same time. It's the same distance, this direction as this direction. So when the light recombines, the waves of light are recombined in phase with each other. And they don't have constructive or destructive interference. They recombine, and it's as if they didn't get separated. Now, if while the light is traveling, this device rotates, right? So it initially came from here, right? But now it's rotated. I'll do it more, right? So let's say while the light travels around it, it rotates, let's say a quarter of a turn. It'd be way less than that, but let's say just for the illustration. So now the light that started going this direction has right, it started here, right? It started going while it was moving it had to get all the way to there. It had to take a longer trip to get there. Now the light that's going this direction, while it's moving, well, the apparatus moved and it had a shorter trip. Okay, so one path was longer, one path was shorter. This is because the speed of light is the same. I'll expand that for a second later. Anyway, so then when it's recombined, there are constructive and destructive interference patterns that are read on the whatever plate or device you're using to measure it on. So if light did not have a constant speed, then for example, let's imagine that this was like a train, right? A train track on a piece of plywood. And you had two trains and they went opposite directions around the same length of track. But the relative speed between the train and the train track, well, the engine on the train, it can only make it go so fast. So it keeps it the same rate. And so by the time it when you start moving the apparatus, the train going this direction gets moved faster relative to out here. And the train going this direction gets moved slower in relation to somebody sitting up where you are in the camera. So that's how we often think of things, is that the medium in which it's going through moves it faster or slower. And that's what Alan is talking about. And also, so when Alan's like, oh, that they've never explained it using relativity, well, or derived it from relativity. Well, I just did with relativity, the constant speed of light. So just because the apparatus is moving doesn't mean that the apparatus movement is making the light travel faster or travel slower, right? All right. So let's go back to this.
Maximum dimensions in that in that speed difference throughout the day, which corresponds to sidereal time when they plot it on a graph. So they equate that to Earth rotation. 1 second. So the consequences are that the speed of light is slightly faster and slightly slower, and it's measured relative to the velocity of the observer. There's no real consequence or anything that's going to break it or whatever, right? Because actually, what Einstein proposed to solve Galilean invariance for Maxwell's equations was to use partial differentials for the time coordinates, right? And on the inverse of that, you can use absolute time in a partial differential for the moving frame, but the math is more rigorous, and it's actually, but it leads to first order invariance, because when you do that, there's a leftover velocity component that you can use for the observer, and that was known as the Maxwell-Hertz equations. Now, those were, disregarded in favor of Einstein's theory.
So, but you're not quite answering the question, though, and I'm not sure what you're. Sorry. So
there's no mathematical. There's no consequences, dude. They both use the same. They both use the same. Like the problem was the same. They just solved it slightly differently. One uses absolute time and a differential for the moving frame, and the other one uses two differentials for time. Like
But let's put this out though a little bit, because what I asked was, under the assumption that neither of those explained the anisotropy, there would be consequences for the Maxwell equations, and I'm not sure you understand what those consequences would be. Shane, do you have a response to that?
I'm waiting to go back to the lab frame with Peter. So whenever you guys are done.
drink every time Shame has something useful to contribute. No drinks taken.
Well, I just think that this one's important because
the speed of light's never been measured as isotropic, though, right? Like when it comes down to interferometry measurements, the speed varies relative to the latitude, so the consequences aren't as dire.
Oh my gosh, the speed varies based on the latitude? What the hell is that? Alan, Sealion, any idea what he's talking about there? I don't know what, like, they like to misinterpret things. I don't know what he's misinterpreting for that. Is Wang's lab frame. So there is a it's Ruyan Wang, right? There's a guy from who did some work in Minnesota at St. Cloud State University, where he made an apparatus where he had he's like it's a linearized Sagnac. So this is a Sagnac effect, they call it, and he linearized it. So had a box that output all of this stuff was in a box, and then it went through a fiber optic cable, and that fiber optic cable was on, like, this had these something like this, I think is no, that's not quite right. I'm trying to remember exactly how it was done. So I think it was more like, let's forget that. Let's say it's like this, and a small roller here, and a small roller here. So then what happened is, kind of looking like a goofy face there. The fiber optic cable, I'll make this the fiber optic cable. It went like this, right? Something like this. I hooked it up the wrong way, but the point is that and then they looped it a whole bunch of times, and it went this way, right? And then this was loose. So they had this as close as possible to each other and had as little of an inside the loop as possible. So the Sagnac effect is directly proportional to the square, the area, right? Inside the loop. So this, if you make this bigger and rotate it at the same rate, the effect here is bigger. So when you're trying to measure the rotation of something very precisely, you want this bigger. That's a good thing. One way to do it is to loop it multiple times around. So you could do it in a fiber optic cable and loop it 1,000 times, and then you're going to get a much magnified effect. Or like the large Earth measuring interferometers, they have really large areas here that they're encasing. So when they did this one here, they reduced the amount that was inside the loop. That'd be this and this, and most of it's just this linear area here. So they've got, it moving one direction here and moving the other direction there, and they're like, oh well, we still measure an interferometry they're out of phase when they recombine here, and yep, that's because just like this one here, the distance this way and the distance this way, because the light split and went both directions, the light path was longer one direction than the other direction based on the way the apparatus was moving. And they're like, oh, east-west. No, not east-west. Just took longer because it was a longer path. So, Sealion Prime, you sent me the, yeah, right. I'm drawing it from memory, so certainly could be incorrect. So there you go. Yep. Well, that's not the one I was thinking of, but it's fine. It's fine. It's all good. Let me. A good video coming out tomorrow by Will. Just tell you that. That'll be a real barn burner. All right. So, Sealion, why is your name Mordwand and not Sealion? What's the reason for that? Okay. All right. So there it is. There's a, yeah, it's not, mine isn't too bad, is it? So, all right, so they didn't get this little bogey wheel here, they didn't have in that. So I don't know if it's there, if they simplified it out, or if it was just a it wasn't actually there, and I was just thinking it was. But anyway, so they took the thing that says FOG, that's the fiber optic gyroscope, that is on a little slide, and then it's got two fiber optic cables that go up to the loop that's around those wheels. And then that over on the right side, there's that extra wheel over on the right. That's to slide the carriage that moves the fiber optic gyroscope so that the little lead fiber optic cables that go from the FOG unit up to the loops of fibers there, so that where it hooks in and where the device sits moves with it, so they slide next to each other. That's why it's there. So, and and they found through measurements that the phase difference was based on the length. No surprise, just like I said here, you make this longer to get more of to increase your reading. So yep, speed times fiber length, meters per second, meters squared per second. So meters squared, that's an area, right? Square meters. So, right. And so what was he saying? He's talking about east-west. So I don't know why he's talking about that. It's I don't know, bro. We'll see what he has to say here.
We're making it.
Okay, well, let's dig into that a little bit. So where's your evidence?
Your question has been answered in full. My evidence is all interferometry experiments that measure the speed of light being varied relative to the latitude.
Maybe we can answer this question in a simpler way, or reset a little bit. So I am a little bit confused. I heard from Alan that there is an absolute lab frame. It is on Earth. We agree. Within the Earth, we can narrow this down to the Earth. Within the Earth, though, and this is where I'm not getting it, maybe Shane can explain, speed of light is constant for two observers or is not? Which is your claim? Our claim is that it is constant. If I am moving away from Sealion on Earth on a train, I will not be running away from light. I will still measure the speed of light to be c, or whatever it is in air, and he will measure it as such. And he's not in a better place in Colorado than I am in Washington, where light travels differently, or there's a select direction in which it tends to travel. Can you explain that? Where is the absolute lab frame? Where is it physically located on Earth?
Let's just define lab frame real quick before we get lost in the muck. And you guys have taken 3 running leaps before we started to walk, right? So lab frame, typically defined as the reference frame where the measuring apparatus or observer is at rest, right? You have to have that in the physics experiments. It's compared and contrasted usually with the center of mass frame when doing relativity, right? But one requires constant transformations of results back to one and one does not. Can you guess which one? Absolutely. The lab frame is the only one that doesn't require transformations back to. It's an Earth-based reference, a non-inertial frame for the observer at rest. Now, when you're doing...
Well, that was a lot of stuff really quick. In relativity, your frame of reference is what he just described. So they're going to try to hand wave relativity and talk about stuff like you just described your frame in relativity.
Relativistic considerations in the lab for experimentation, and you're going to say plain fantasy land, you have to put it into a fantasy coordinate system and a fantasy translation. That's why you have covariant transforms and all that wonderful stuff with the math tricks that get played. So when we're talking about where's the lab frame on Earth, Peter, that's a retarded question.
So when I'm moving in relation to... Go ahead.
Because there was something that Alan said that I think was really important, and it would play off of what Shane said. So you had mentioned an issue with measuring the speed of light is isotropic. Could you describe a little bit more why that's an issue and why that has not been measured in your view?
You mean it varies in east-west direction constantly? How is that constant in isotropic? It's definitely not.
So, but let me think about it this way. So if we're in a particular location, is it possible to measure a one-way speed of light within your lab frame?
Yes, using GPS, those are one-way measurements of the speed of light.
So wait a minute. So the GPS is within your lab frame?
GPS sends signals one way
It's not in your lab frame.
from the satellite to your receiver. That's measured with a time difference.
In an Earth-centered, right?
So that's a one-way speed.
Wow. You know, measuring the one-way speed of light is probably a Nobel Prize type accomplishment. I haven't heard. Maybe this year, maybe next year will be the one where that gets the prize. Or not. Maybe they just don't quite get it.
So your claim is that GPS provides a one-way measurement of the speed of light. Could you support that with research? When has that been measured?
The range measurement equation every time it snapshots
Every time GPS is used. So
Can you walk us through it? Walk us through it step by step.
Hold on.
Yeah, so a measurement of the speed of light is different than a usage of the speed of light. So in order to measure it's a challenge to measure the one-way speed of light. Try to give you a really brief one explanation. Let's say you're gonna bounce light off of something, right? You're here. You've got a light emitter, and then you've got a mirror over there, and then you've got a receiver over here, and you're going to send a pulse, and then you're going to time how long it takes to go there and come back, right? That's not a one-way speed of light. That's a two-way speed of light. You went there to there, and you went back. You're like, oh yeah, okay. That's a two-way. Okay, so how do we do that? Well, let's have the emitter here, and let's have the receiver here, and let's just know what time we sent the pulse and received the pulse, right? That sounds really simple. Now you could do that with the one-way speed of sound, for example. You just get a really accurate clock, accurate to, something that's depends on how far away you are, right? If it's just a couple meters away, you'd need it down to a thousandth of a second, or maybe more than that. But the problem is that with light, the amount of time, or so the amount of time precision that you need is very, very high. So when you move, the act of moving the clock, it has a relativistic effect on the clock that you're moving. So when you move it from here to here, there's an effect on that clock. So now it's not in sync with the clock over there. So when you send the light pulse and you receive it over here, your clocks are not the same. They're not synced anymore. It seems weird. It does. I think Veritasium has a video on it. Is it Veritasium? Might be. Anyway. Sealion Prime says, change my view. Ether cosmology is just flat Earth with extra steps. Well, it's worse than that, Sealion. Ether cosmology is flat Earth destruction, right? Throw away flat Earth. Step one. Right? Then, in their mind, prove ether. Then number two, question mark. Then number three, flat Earth. Right? They basically they start with, well, if relativity is fake, then the Earth is flat. Then the globe can't be real. No, that's not it. All right. There you go. We got some Veritasium links, people. There you go. So it's an interesting thing. People thought maybe, hey, could that, I mentioned earlier, Ole Romer and his measurement of the time difference of Jupiter's moon Io getting occulted into the shadow of Jupiter. Is that a one-way measurement of the speed of light? Because, we're close to Jupiter, we're far from Jupiter, right? No, because we moved. Moving screws with the clock. So, all right. Oh, AT2 Productions. He says, how about this? A timing oscilloscope with two photosensors. One is the trigger, the second is the detection. That'll give you the time between the two sensors with one clock. Problem there? Well, if they are separated by a distance, right? The two photosensors. One is the trigger, the second is the detection. How is a photosensor the trigger? Is it like you've got a light source here, you've got one photosensor here, another photosensor here, right? And then how are they connected? With wires? And how fast does the light, the signal go through the wire? Speed of light? I think, yeah, I'm not the one, dude. Jared, if you wanna get that prize, I will cheer you on. But I have a suspicion that's not it. So, separated by a known distance in the lab, one sensor is a trigger. Input to the oscilloscope. Use the same length cables. Okay. It sounds at first flush, like it might make sense, but relativity is weird. So my guess is, again, it's probably something that we're both missing, because I don't know what's missing there. So anyway. Oh, is Axeman, let's see. Axeman says, someone interested in the truth seeks to prove themselves wrong. You need to go look critically at your religious belief in the science. Oh, Axeman, that's precious. The projection is real. All right, let's keep going here.
Yeah, I got you. So check this out. And this will answer Peter's questions too about the speed of light and who can measure it with what, right? So suppose you have a moving train with people on it and they all have GPS receivers, and suppose there's a stationary lad on a platform with a GPS receiver. At the time where the train intersects with the stationary lad, a GPS signal hits the train and the lad that's on the platform. Everybody gets their signals, but there will be a proportional delay to the observers in the moving frame, right? It's just like any other wave. Sonar works the exact same way, and it uses the same range measurement equation.
So what is the range measurement equation? What is the distinction between range and pseudo range for GPS?
The range measurement equation tells you the distance based off, well, it sends a snapshot of the time of when the satellite, where its location was in coordinates, and then you get the difference of when it was received times the speed of light.
Something like R sub r, T sub r minus R sub s, T sub s equals what? C times T of r minus T of s, which is the actual range measurement equation in ECI, right?
So you have a precise one-way speed of light measurement from GPS to any location on the Earth?
Why do you think a lab frame is location dependent, dude?
Anywhere that you get the GPS signal, yeah.
Okay. So there will be no variance in GPS signal as a function of distance?
No, there's explicitly a timing delay based on your velocity. That's how GPS measures your position accurately without having to make further adjustments.
And what do you mean by further adjustments?
So if the speed of light was isotropic and constant for someone moving at a
isotropic, meaning not changing,
a constant velocity, the timing difference wouldn't work out for them, right?
So let me walk through this a little bit. So you have a GPS satellite, right? And we don't necessarily know, what it is. Let's just say, for the sake of argument, it's up there somewhere, right? So it's sending a signal down. Your claim is that's going to be a one-way signal, and we can use that to measure the one-way speed of light. What I'm asking you, first of all, I'd like to see the paper to support that. I'm not seeing that yet, so if you could provide that, that'd be great. I'm pretty sure I know which one you're talking about, but I'd love to talk through the details. But what I'm wondering is if you consider that an experiment or not.
I consider it a measurement.
Okay, so it's a measurement. Is it a first order or second order measurement?
First.
It's a first order measurement.
Yep.
So walk me through the difference between a first order and a second order measurement, please.
So
one of Alan's favorite topics.
Second order measure, or a first order measurement, is when the thing that you introduce has a directly proportional relationship to the measurement. In the example of Sagnac, for example, when you're measuring light, the exact rotation of the table produces the fringe pattern. So that's a first order effect, velocity, and then the measurement of the corresponding fringe that's directly proportional to the velocity is a first order measurement. second
So
order measurement.
directly proportional. That's interesting because to my mind, it seems like there's some adjustments that need to be done in calculations by your own admission. You mentioned velocity of GPS satellites, right? Can you prove that? What do you mean by directly proportional? What do you mean by directly proportional in your definition of first order effect?
Are you for real? Is that a real question?
Yeah, that's a real question. Yeah, just walk me through it because I need to know that that's not clear as a.
I gave you an example of how velocity would cause a variance.
About it. I'm just trying to clarify
I already clarified it in my original answer.
Well, is it linear or nonlinear? Does that make a difference?
What does proportional mean?
First order is more qualitative, second order is more quantitative, right? You get precise and you have measurements and tools using external stuff, right? So let's just get past it. What's your actual point, Mortal One?
My actual point.
Wait. First order is qualitative? There's no measurements or numbers in first order? I don't know where he's getting that from.
So we've conceded now that this isn't an experiment. It's a measurement.
You said it was a measurement from the first. Who conceded what?
We're on the same page. This is not an experiment.
That's a different way to say the same thing. Sure.
Do you believe that the scientific method doesn't require an experiment?
It does.
All right. So we're getting a little off into the weeds here with dog shit.
I think this is important.
Okay, go ahead, continue.
So I just want to understand and the reason for this is I have a definition of the scientific method from your website and your epistemology of science. And according to your scientific method as recorded on your website, I'm sorry, I don't have the exact link, but I can provide it to you. You come from a framework of realism, an objective world exists outside the mind. That's great. Scientific method, and specifically mentioning an experiment. So there's no experiment that has measured the one-way speed of light, is there?
Well, there was the resonance cavity experiment done in 2019, where they said that they, measured the isotropy of the speed of light, but the things that they accounted for to get the measurement for C to equal C, they accounted for sidereal effects in seasonal effects, i.e. the things that Miller found when he measured the periodicity relative to the position of the sun and the stars throughout the year.
But this is another measurement. This isn't another experiment, is it? What's the independent variable?
So this is great. So if you're unfamiliar with it, flat earthers have this super dogmatic version of the scientific method that they think is necessary. They don't actually think it's necessary. It's the thing that they use to attempt to discredit or discard the things that they don't like. So if you bring them some science, right? Then they'll pull out their checklist. They're like, oh, well, here's the dogmatic version of what our masters have said is the scientific method. And if it doesn't match the scientific method, then it's all gone. We can't accept it. So, and it's so rigid and dogmatic that absolutely nothing actually fits it, right? Nothing fits their definition of the scientific method, right? So if you ever, it's an interesting way to do this. Take their dogmatic view and say, well, let's apply your required version of the scientific method to this thing that you just said was an experiment, because it's designed to reject everything, right? The flat earthers, they'll find an experiment. They won't put it against their own dogma, because they don't believe it. They don't use it. They don't care. They don't do experiments. But they'll find something that doesn't match that. They don't care. They never test it, right? So this is fantastic. What's the independent variable? So they're like, you start with a naturally observable phenomenon, and then you have to have I don't remember. That's not how science is done. So I haven't put it in my head. Anyway, they said that you have to have an independent variable and a dependent variable. So another one of the things they do, like, what are the independent variable and dependent variable? That's one of the things that they use. They're like, if you can't instantly state what those things are, out. And the one that uses this the most is Nathan Oakley and Quantum Eraser, and they will mute you. They'll bark over you. They'll say, what's the independent variable? And you'll say two words, and then they'll say, oh, so you don't have an independent variable. You don't know. You didn't even listen. So, but this is good. What is the independent variable in that measurement?
I'm not sure. I have to go look at that one again. I just know they used a resonant cavity to make their measurement.
Yeah, but I mean,
they're just projecting it outward.
You would agree, right? That
okay. You want to get to experiments? Then let's go over all interferometry. Okay. But before we get there, I just want to stop. No. The independent variable is the.
Okay, just chill. It's cool.
Good.
Yeah, I'm good.
Yeah, let's not spiral, guys. Let's not spiral.
So the independent variables are the direction of the device and the measurements taken throughout the day. If your hypothesis is that throughout the day you'll be aligned with certain directions of motion, that you'll be able to measure those. That's why we move this back.
So is time of day something that can be manipulated?
No.
That's another. Oh my gosh. So good. Because Nathan Oakley and his clown troupe over there, they have said that time cannot be an independent variable, when in fact it is almost always an independent variable. In fact, if you're growing, you're doing an experiment where you're growing things, corn, right? We're gonna put some. Treat some corn here with something to see if it produces better, and we're gonna not treat it here, right? You varied that, but you know what else? What else happened? Time passed. You didn't get to not have time pass between when you put the stuff on and when you check to see what the stuff did. It was an independent variable. So there's typically more than one independent variable. Time being one that's always there, almost always.
So then
the direction variable. Well, in conjunction with the orientation of the device, it is.
In conjunction with the orientation of the device, you can adjust your time of day. Explain that to me.
Yeah. So when the device is orientated north-south, right, at a specific time of day, you'll turn it in a circle, and the measurements will differ as you turn it.
Okay, so you're saying now that there's a time of day that I can't manipulate, and that's sort of like a shadow variable, and there's a direction of device that you're saying I can manipulate. Is the direction of the device relative to an absolute lab frame, and how would that be determined based on latitude?
The device is on Earth, so it's in the absolute lab frame, and secondarily, when you turn the device, that will show you if the variances corresponded to the time of day and the direction that it's orientated with. Now, the reason. The hypothesis was that, based on the orientation throughout the day, when Earth's direction of motion, where it'll be aligned and not aligned with it, it'll get the minimum and maximum readings. So you do that by turning the device with respect to the time of day to get the minimum and maximum readings to find out if the time of day is truly affecting the measurements, which is what all interferometry experiments did at that time.
Earth's direction of motion? Did you just mention that?
Didn't you say in your opener that you guys adopted the Aether cosmology, like the Aether framework, and that actually you said that there was a measurement of Aether?
Hold on, that was good. Shame had to jump in. You just asked. What did you just ask there? Movement, the direction of movement. He thinks the Earth is flat and doesn't move. So did Alan just claim the movement of the device that was sitting on the surface of the Earth?
That it did vary at the same latitude and altitude. Was that not in your opener?
No.
I didn't talk about wind speed.
Let me answer that question. That's a great question, Shane. Thank you. Would you like me to pull up the paper related that explains Dayton Miller within the context of the quadratic Sagnac effect that describes why it's not an etheric wind? Or we can talk about. Yeah, absolutely. So. You're aware, correct, that there's something called the international gravity formula? Could you describe the two terms of that formula?
No, I don't know what that is.
Okay, great. So the international...
Once again, Mormons are safe if they're drinking every time he adds value.
Gravity formula describes the relationship of the gravitational potential as measured by local and its effect on local G. There are two terms. There's a potential term related to the oblateness of the Earth, and then there is a second term related to the rotation of the Earth. So basically, all the quadratic Sagnac effect is saying is, in the same way of all interferometry, we make a measurement of the effect on the device within that frame from those two effects. So that creates what's called a quadratic effect. And all that really is just saying is it's a perfectly consistent relativistic explanation of Dayton-Miller. So there's no concession of ether wind. I want to get to the ether wind topic, though. So you mentioned that there's an absolute frame. So the Earth itself is an absolute frame, correct? The entire Earth.
I'm not going to keep answering the same question over and over
We
again.
explained it.
Okay, so yes, that's the case.
That's what I got.
Okay, so would there be any isotropy in the measurement of the one-way speed of light as a function of your location on the Earth?
Ashton Richards, are the Mormons the same as LDS or Latter-day Saints? Yes. And I should have said Latter-day Saints. That is the term they prefer now instead of Mormons. But I think for the most part, they don't. I know quite a few. They're big into ultimate frisbee. The Utah team is a fantastic team, and the national championship for the pros was in Utah this year. They're super excited to host it. And just so you know, Minnesota won. So we won the Super Bowl of ultimate frisbee. And my kids know a couple of the players.
Only in the north-south direction
In the north-south direction. How do you measure that direction?
with GPS.
So you're reifying your model by using GPS to put in second-order calculations to inform something that's not an experiment. Okay.
How are we reifying the opposite model when we're using experiment tools and measurements?
I would like to show that.
You haven't provided
Not
any.
what that word means, dude.
Could I, maybe we can reset this. Maybe you can get back to the Sealion, because there was a statement made earlier by Alan, I believe, that there are all these questions about the measurement of the velocity of light, and therefore this whole thing about rotating the ether and time dilation and length contraction are just made up because we don't measure that thing. Well, I would like to go back to what I presented earlier and show a measurement, and this has been done many times but by many people. Here's a measurement. And here are some of the values. I'm going to highlight them on the screen for the audience that are being measured, okay? You guys can see, right?
Mm-hmm.
So this is the measured velocity of a muon. Muon is not light. Muon has mass. It's a particle. It's well studied in laboratory settings. We know its mass. And we can measure its velocity when it comes from the atmosphere at high speed, 0.98 of c, not c, just shy of c. We can measure it. We can measure the momentum. Momentum is mass times velocity. We know the mass from other measurements.
So, by the way, momentum is mass times velocity is yes. But if you ask Gary, who was on a couple weeks ago, he'll be all confused about that.
We certainly know the distance, 10 kilometers. That's easily measured. And we count the number of muons over here and over here. So that's a measure. And now the math simply does not add up. And we also know the half-life of a muon. Very well studied. The math half-life basically means the particle will disappear after a certain amount of time. So we know that this math does not add up if this was an absolute reference frame. There is no way this many muons can cover 10 kilometers in the amount of time that they can be alive. We perform measurements of these things, we add them up, and there is no way. We know, however, when we look at it through the lens of rotating the ether, that time dilation and length contraction perfectly explain this empirically observable and measurable phenomenon. It is shown here. From the point of view of the Earth, there's time dilation occurring when we look at muons. Their clocks seem to be running slower. When we think about it from the position of muon, it's the distance between the two positions that is shortening it. These are empirical measurements. And I want to add one more thing on top of this. One of you mentioned, I loved it earlier, that you want to take us back to empirical measurements, science based on empirical evidence. We all agree that the original intuition of human beings was there should be an absolute frame, there should be some medium filling it, and things should move in relation to.
I want to point out just how stupid their chat is. Joe Mama says at Hammer, Starlink is just the next BS thing. You see it here? You guys look up and see a light in the sky and say, hey, a satellite. Don't you see the insanity here? We don't just look up and see, hey, a satellite. Millions of people point directional antennas up and receive the internet through it. Through something that's up there. So if it's not the rockets that you can actually go and watch get launched, physically see them leave the ground and go up. And if it's not that, and if it's not the videos of the rockets getting distributed into space, because there's videos of those also happening. If it's not that, then what is it? You can't replace an actual rocket actually taking off with thousands of people actually seeing it, and the associated video of that happening with the Earth in the background. You don't get to replace that with nuh-uh. Quote, don't you see the insanity here? Thinking that just saying nuh-uh is an actual response is the insanity. Joe Mom. All right.
It is only through empirical study of nature and empirical measurements that we have realized that our original intuition was simply wrong, which is nothing to be ashamed of. We're just human beings, and we learn about the true nature of nature, dare I say.
All right, cool. I'm going to answer this question, and then you guys are going to answer some questions. All right, so one, like you said, you've never weighed a muon. It's derived algebraically based on its energy and velocity. Two, you don't know where that muon that you're measuring was created. The hypothesis is that cosmic rays hit material in the upper atmosphere, then there's some particle pair collisions, and then a muon pops out.
Now, is he going to present? So he's done this before. So there's more muons at high elevation than at low elevation. The mechanism by which they are generated is understood and makes sense based on empirical science. Now, he's going to take that there and just provide a nuh-uh for it, right? Why are there more muons at higher elevation than lower elevation? He won't present anything. He'll just say, we don't know. No. Alan, you don't know. But the people that understand this, which doesn't include flat earthers, when you draw the Venn diagram of people that understand muons and people that don't understand muons, right? You're not on the same piece of paper as people that understand muons and people that don't understand muons. You're on a piece of paper 1 billion miles that way. There's one little circle that says flat earthers over there that's also don't understand muons.
Based off of its half-life alone, you don't know where it was created. So the hypothesis that it had to be created up here and it's measured down here, therefore link contraction time dilation is a cool story.
So a cool story. So he's not providing anything. We absolutely know it. We don't really need to know for this particular experiment where they were created specifically or how they were created. All we need to know is that there are more at high elevation than at low elevation. How is that possible? He provides nothing. What a loser.
Now, back to the Michelson, Gale, Pearson, and interferometry and stuff like that. So, here we go. Let's pull this up.
Can I address this? I'm sorry, you're misrepresenting my position. We know where muons are generated. We don't have to go into why they are generated. We simply know there's a certain altitude where a lot of them show up. Above it, they don't show up. Below it, there's fewer and fewer and fewer and fewer of
Good job, Sealion. I like this.
them. We don't have to talk about
Oh, Peter, not Sealion. Sorry.
how they come to be or what mechanism causes that. We simply measure the amount of them. It's zero or close to zero above a certain altitude. Then suddenly there's a lot. There's fewer and fewer. We have measured their mass in laboratory settings ad nauseum, and we know, therefore we can measure their velocity. And we certainly know the distance from ground up to the place where a lot of them show up magically. That's a simple measurement. All of these are simple measurements. Some of them are more involved because you need precise laboratory equipment to study a muon. But all this is routinely done.
And the other thing,
so
This is empirical.
No.
This is empiricism.
in order for your hypothesis to be true, it would have to have been created at a different altitude than what it's measured at. That's a cool story, but it's irrelevant. It doesn't give you mutual
How is that not relevant?
exclusivity.
So whenever they say cool story, that's an escape mechanism. Just understand that. It's common in all these flat earthers. Austin says it. Nathan Thompson said it a lot, right? If they don't have any answer for something, they can't provide an actual alternative. They just say cool story, right? And only the idiots think that cool story is an appropriate response to actual physical empirical measurements.
Because you don't know where it started at. You're just making a measurement, and you're just making a measurement in the sky, and you're like, oh, it would have actually had to start it up here even further, but because of link contraction and time dilation, we measure it here, dude.
That's not what happens. We know where they show up. We have measurements of that.
Oh, all right, your position's noted. All right.
Okay, now present your position. Present that this is not true. Present empirical evidence. Stop hand-waving mythical ether. Show us empirical ether.
That depends on time dilation being a factor, because even when you're looking at it, right, you're depending that muons are up in the upper atmosphere, Lorentz contracting away, and that you have a time dilation effect before it hits the ground. And that's what makes your empiricism make sense, but really it's just oscillation. You're just decaying a cesium atom, maintaining that oscillation rate consistently.
There's no cesium atoms involved. What the hell are you talking about? You are useless, Shame. Why was he here? Just for the Laurel and Hardy guy? Oh my gosh.
I know.
Where's the cesium atom here? Where's the cesium atom in this experiment?
You're talking about time dilation, right? So you're assuming that that's happening in full propensity and correctness
in
for
this
your measurements
particular
to make sense.
experiment, I'm not measuring time. I'm not employing atomic
For a
clocks here.
muon to be a measurement, to take a register, right? For it to register, you're assuming that it's from somewhere and that in the atmosphere it's actually Lorentz contracted, right?
He's not answering. I think he talked out of his ass and is realizing that there is no cesium atom involved in this. There's no clock involved in this.
Right here, when it says muon flux, that's measured.
No,
the flux is measured.
you don't know where muon detection comes from. You're just gonna measure it and say that actually it's based on empiricism.
Why don't you explain it to us, Shane? Where does muon detection come from? How are muons detected, and what do you think they are?
Listen, when you're going to take a measurement of muons, right, from muons, radioactive particles from cosmic rays, right, in the distance, you're taking it from this part, right, in the atmosphere where the muon is at rest, but actually the atmosphere is Lorentz contracting. You have a time-dilated effect for it to be measured, and from that, you're assuming all this nonsense about cesium atoms, which is decaying at a constant rate, right? And it has, what?
There's no cesium atoms involved.
What's the rate, Alan?
The half-life?
That's relevant.
Yeah.
So there's two things that I'd like to pull on there. So you make a mention of cosmic rays, and I did actually read your website description about this. So I'm wondering what your explanation for this phenomena is in relation to cosmic rays, and in particular, are cosmic rays inside or outside of the absolute lab frame?
Do we know cosmic rays definitely produce muons that are detected on Earth for certainty?
We don't need to. Not for this argument.
That's the hypothesis of the mainstream narrative.
It doesn't matter.
No, we know where the muons show up in our atmosphere. We don't need to discuss how exactly they come to show up. They just show up.
We just know they're there.
If you don't discuss where they came from, then how, dude?
Because it's not relevant to this conversation.
Oh, the desperation from Alan. Like, if you don't know where they came from, then how can you talk about it? It doesn't matter. They could have come from unicorns. It doesn't change that they are there, and it doesn't change that they have a half-life of 2.2 microseconds. It doesn't change anything.
No, they show up there, and that's it.
But
And I
you're
think
saying they only show up there, right? Because of link contraction
Not
and time
only.
dilation.
Not only.
No, that's actually a mischaracterization. They don't show up there because of time dilation and length contraction. But the reason that so many of them make it down to the surface, and Shane also misstated this, the atmosphere is not length contracting. It is within the frame of the muon itself that we're observing these effects. And Shane, I would like to pull on that because you seem to think that we don't understand how these are measured. So how would you measure this phenomena? And would you do it within an absolute frame or a relative frame?
Well, my position doesn't need made-up particles to make things that aren't in motion.
How are
pretend
these
to be in
made-up
motion,
particles?
right? So we don't need made-up particles, too.
They're not made of particles. The desperation here, it's just denialism. It's not a reasonable way to engage in a debate about something to just say it's made up. It's not made up. There's lots of empirical evidence for it. And he's the one, Shame is the one that in his introduction said we need to return to empiricism. This is from empiricism.
Defend a muon is retarded in the first place. You know why? Their whole purpose is to keep the framework of relativity in place. It's
Muons have nothing to do with relativity. They have nothing to do.
It's one of like 7 different discoveries that they had to stack on.
I'm sorry, strawmanning. This is absolute
Jesus
misrepresentation of our position. Muons have nothing to do with relativity. Muons are studied through the standard model of particle physics, which is completely detached from general theory of relativity at the moment in physics. Muons are subatomic particles that are well understood. Same way we understand electrons, same way we understand protons and neutrons. They're well understood in complete isolation of this experiment. That's how we know their half-life. That's how we know their mass. We observe them. We can create them ourselves.
Okay, so for reference, a muon is a subatomic particle. So you've got there are leptons. There are 3 main leptons. You've got there are 3 leptons: electron, muon, tau. They've all got their anti-version as well. The anti-electron is usually called a positron. That's what Data's brain was made from. Wouldn't actually work in reality, but it's a good thing for sci-fi. Muons have a very short half-life, 2.2 microseconds. It's not long. You don't get to go that far in that amount of time even if you're traveling very fast. So you wouldn't get from the top of the mountain to the bottom of a mountain in 2.2 microseconds, traveling at the rate that they travel, right? And their speed is known through other mechanisms. So how is it possible? And Shame says they're made up particles. They're not. Peter is like, we know that they exist. The evidence about them isn't related to general relativity at all. It's different from that. How they're examined and how they're known to exist. It's just desperation from Shame. And let's see, does anybody in the chat here, I don't know, is anybody in their chat saying, oh yeah, that makes sense? No. Nope, none of them are saying, oh yeah, Shame, they're made up.
Observe them being created at a certain altitude or range of altitudes. We know this. We didn't make that up. And then we ask ourselves a question: how come a certain measured amount of them make it to the Earth? It is counterintuitive. They should not all make it in that amount to the Earth, because statistically speaking, they should all disappear on their way there. This shows you length contraction from the perspective of the muon and time dilation from the perspective of the stationary observer in relation to the muon.
Who was the
Only if you stop for a second. Only if you assume that the muon was created at the upper atmosphere and then it ended up all the way down here. You don't know where the one that you measured down here is at. Just because you make anomalous measurements doesn't mean you can just start link contracting and time dilating to reaffirm your model. Now, you measure
this
them
is
with
evidence for my model. This is evidence for my model because there is no other known explanation at the moment.
When you address the creation and tracking it, right? That's where you're just asserting it.
I just addressed.
Somebody said in the chat, said, if you get hit in the face by a ball, but you didn't see the person throwing it, you still got hit in the face. Right? You don't need to know the mechanism by which it was created or where it was created. All that they look at is, there's muons here. There's muons here. We know how long a muon lives. We know what speed it moves. We know the elevation. We know the elevation. That's it. Where it came from doesn't matter. And so this is just Alan just dying. This is just the death of his position to just say nah without presenting any at all, without even the slightest attempt to offer an explanation for it. How did the muons get there? Don't know. They're there. Okay? And yet, down at the bottom, they're also there. Where did they come from, Alan? You don't have an answer. Your denialism is rejected.
That's why you're stop interrupting me. That's why you said, "Oh, I don't want to discuss that. We know they're up here, blah blah blah." Right? But you don't even know why they're. What's the cause of what they? What produces them anyway?
Because we're not discussing the standard model.
Do me a favor. Can we? When the other guy's talking, let's mute up. That's kind of the point where I shouldn't be over talking each other. And I let it go for as long as I can, but just make sure that you are only talking when it's your turn. Okay, thank you. So go ahead. I'll let you, Alan. Go ahead, speak from now. If you guys can mute, that'd be great.
Thank you.
So if you have a problem with something that he says, you don't agree, just remember it so that when it's your turn, you can point out that it was fallacious or a straw man, whatever you need to point out.
Okay. Peter says Alan was so desperate to move on from that topic, we didn't let them. So I haven't watched what's coming up, but Jaron just gave the floor to Alan. My guess is Alan is going to run away from the topic.
All right. Just because you measure muons on the Earth doesn't mean they came from the upper atmosphere. They have a half-life of microsecond, right? Fractions of a second. You don't know where they were. You don't know where they originated at. To assert that it came from the atmosphere due to link contraction and time.
And here we have Witsit, who whines and complains when people accuse him of being a grifter. Who's like, we don't make much money doing this. So why would we grift on this? Well, of course, Dearth makes a lot of money, but Austin, who definitely doesn't want anybody to ever think that he makes money from this, has just dropped a super chat there. Again, showing the absolute failure. This is his super chat. Austin's super chat here. Witsit gets it. This is waving the white flag. This is admitting defeat. What is the source of the muons? It doesn't matter. They exist. What is the starting position? Doesn't matter. They exist. Doesn't change that they exist. How can you invoke contraction of distance without specifying the initial source? Easy. We know they exist here. We know they exist here. In a number that's impossible without length contraction. That's how. How many were up here? Doesn't matter. How did they come from up here? Doesn't matter. This is them just lying on the floor. This is bugs with their feet up, doing that little death twitch. That's it.
It's just your assertion. Okay. Now, that's all I have to say on that. Now go ahead and make your counterpoint to that, and then we're gonna move on.
It's dependent, by the way. Muons are the example of time delay. That's why it's important.
They're not an example of anything. So let me address a few things.
Okay.
Well, Shane,
okay, go ahead.
Let me address a few things. First of all, the reason why I'm refusing to discuss how muons are created is because today we're not discussing the standard model of particle physics. or discussing general relativity. Second of all, the reason why we know where they come from is because we probe different places looking for muons. If we go too high up, they're not there. If we go to a certain altitude, there's a lot of them. If we go a little bit lower, there's fewer of them. And guess what? They're coming from above us. They're not coming from random directions. They're shooting down at us. We measure lower, we measure lower, we measure at the ground. So unless you're postulating that muons are manifesting themselves magically in random locations, and there's no causal effect of them being produced somewhere and traveling in a given direction with a certain velocity, unless you postulate that there's some fluctuations of some mysterious field, is that the argument you're making? You would have to show that.
Yeah, that's my argument.
Okay, the default...
Whoa, Peter, I thought that was a sarcastic question, and now that's his argument. Alan, you need to substantiate that now. He won't.
Logical position is they show up, they travel in a direction, and they decay on their way down. And then there's a question, how come they're not decaying enough? And when you introduce the concept of rotating ether, my friend, then you get the answer to that. This is empirical evidence for the fact that there's time dilation and length contraction occurring due to relative velocity. And I won't even pick on the fact that you guys mentioned several times that it's one of the observers that's contracting, because that's hilarious.
All right, so we're actually going to touch on that specifically now. All right, so we're moving on from muons. My position was already stated before, so we're good to go. Now, we're going to talk about relativity of simultaneity.
Okay. That was great. An absolutely fantastic interchange, and the flatties have no clue. They have no clue that that was such an absolute failure for the anti-relativists there. Right? In the end, he made an absolutely ridiculous claim saying that there's something that just makes them happen. How did he get there? It's insane. I can't believe it that he actually made that claim. And then it went back to him and he didn't provide evidence for it. I know why. Because there is none. There is no evidence for his position on how muons are created. All right, let me read a few here. Sealion Prime says, game time started. Oh, yeah, it got good here. Icy Spin says, this debate format reminds me a lot of Updog. What's Updog? Tim Davidson says, are you flabbergasted by the filibuster? Petulant to the pontification? Enamored at the endless ramble? Insolent to the idiots? Oh yes, I am. Oh, you know what? I need to end this. Which of you voted yes on this? Have you reviewed the math of the Big Bang? 17% said yes out of 311 votes. So let me pull out the oh no, here it is. We had to pull up the calculator here. Yesterday, I walk over here and the dog is chewing on this whole thing. There's some teeth marks there now. Silly donkey. All right. 311, 17, 52 people, 52.87 people said yes. You have looked at the math of relativity. Interesting. I never have. Did anybody hit yes sarcastically? Reviewed it, yes. Understood it, not so much. Yeah, that's all right. That makes sense. Okay. Sealion Prime says, does ether need a container? Now, this is an interesting thing. So they say that you can't measure, you can't use the Michelson-Morley type interferometer in the basement of a building that's got a whole bunch of stone in it and all that, because and you can't do it in LIGO. LIGO can't do it because it's inside of a metal tube, and that metal tube isolates the ether from getting through. It acts as a container to prevent the ether from getting in there and imparting an effect on it. So let me make this clear. Michelson-Morley did not measure within their margin of error of their instrument a fringe shift, as they say, right? And they were expecting, with the hypothesized undulating theory of light luminiferous ether, that they would as the Earth moved through it, right? And that wasn't Earth stationary. That was Earth was already measured centuries before to be moving. This didn't contradict. This didn't like beat out any of those other things, right? James Bradley's measurement didn't go away because the Michelson-Morley experiment happened, right? It wasn't on the table because it is already confirmed, right? So, right, and everything is available to be shown wrong in science, of course, but when there's a whole bunch of stuff for something, you have a high bar to get past it. So when they're like, well, the flatties are like, they think the discussion was or should have been, well, maybe the Earth is stationary. No, the discussion was, well, maybe our understanding of luminiferous ether is wrong. And even more to the point, maybe the complete idea of the luminiferous ether is incorrect completely, and that there's a different mechanism for light. Michelson-Morley, they're like, oh, they only measured a little bit because there's a little margin of error, there's a little bit of noise in their measurements. Like, oh, that was the movement. So Dayton Miller, first name Dayton, last name Miller, not to be confused. The Michelson-Morley experiment is two people, last names Michelson and Morley. Dayton Miller is one guy, first name Dayton, last name Miller. Why does he have two last names? Some people have two last names. So Dayton Miller saw, oh, that's the motion of the ether that they did get. Let's do it not in the basement where it's isolated from the ether, right? Where you're blocking the ether by the building. Let's do it on the top of a mountain, and let's have instead of, rigid walls, let's have tarp walls of some sort, right? So like a tent, right? Never mind, that might maybe have a little bit of, might change the temperature a bit. It's an instrument that's very sensitive to temperature. Anyway, and Dayton Miller's like, okay, well, he thought that he measured the movement of the Earth and the sun, the whole solar system, through space, and he thought there was an absolute space. Anyway, doesn't help the ether guys. But then they're like, the reason why you don't measure the ether movements, the ether wind that Dayton Miller did in LIGO, is because it's inside of that container. And that container shields the ether. Well, if the container can shield ether from getting inside that tube where LIGO is, then the same material could be used to contain ether inside a container. They have to agree that ether can be stored in a container when they say that. So go get a container of ether. They can't. Right? And then we'll bring it to the lab and we'll measure it. Like, oh no, it's immaterial. Well, if it's immaterial, then material couldn't block it. It's the fourth law of Flerf. One thing they say to get out of an explanation contradicts some other thing they say. It does it every single time. I've never seen one thing. It's so consistent. So yes, Sealion Prime, ether does need a container. Tim Davidson says, if you eat pasta and antipasta, does it annihilate? Sealion Prime says, does anyone know of an experiment measuring gas falling due to gravity? As simple of a setup as possible. So yes. And I think you got some answers to it, but I'll answer. Action Lab. Action Lab has a nice experiment with a balloon. Now, he used a latex, a stretchy balloon. I would want to, I think you could improve it by using a Mylar balloon, because Mylar balloons won't expand when you're in that chamber, when you evacuate the air, right? So you've got this balloon that's filled with helium up at the top, you evacuate the air, but then the balloon gets bigger, right? So it's difficult with a balloon like that to get enough helium in it so it floats, but also not enough helium in it so that when the air goes out, that it doesn't expand so much that it bursts. Anyway, he did get a couple that fell down. A much less simple version was, it's almost a year ago, they at CERN manufactured some anti-hydrogen. It's pretty cool. They made anti-protons and anti-electrons and put them together, and they formed anti-hydrogen, and then they trapped the anti-hydrogen inside of a canister, right? It's a gas. The number of molecules of atoms of anti-hydrogen that they made is not many. Like the quantity is not, it's not like it's like 100. It's in the hundreds range. I think not 1,000 is the anyway. So they had it inside of this chamber, and then they opened up and down. They opened valves on the top and bottom, and then allowed them to escape the chamber. And then they counted how many went up and how many went down, and they discovered that more went down than up by far. So that's a gas. It was affected by gravity. Also, it's antimatter, which is affected by gravity the same. There is some hypothesizing that antimatter would respond opposite to gravity that emitted, not really emitted, but gravity that was caused by non-antimatter. So, Steel City JW, why did I picture anti-hydrogen as regular hydrogen, but with an evil mustache? Evil mustaches, yes. So, all right. Steve660 says, tune. Their discussion would all sound so much better with a bluegrass square dance soundtrack in the background. I know. Sealion Prime says, no idea. I don't know what that's about. It was from a little bit ago. Kango44 says, the change in latitude, I think, is reference to Bob Nodell's lies about the fiber optic gyro experiment. That was change in elevation that they claim, not change in latitude. Or maybe the no idea is to that. Yeah. I don't know. This is a new one from them for me. Let's see. So I don't know where that came from. I've never seen anything like that. That change in latitude. Like how much does it change? Is it linear? Is it sine cosine relationship, trigonometric? Is it exponential, logarithmic? What is it? Where's the experiment? Where's the measurement? Nowhere. Yeah, cesium decay. Yeah, Sealion Prime. Did anyone catch Shane saying cesium decay? Yes. Shane has no damn clue. So cesium is used in atomic clocks. It's not the decay of cesium that is part of the measurement. It's the vibration of it, right? That is used. So it doesn't decay. But he said cesium decay in reference to what's on the screen right now. This right here, right? The muons and time dilation. There's no clocks involved in measuring that. He had no clue. He's just talking like, you're talking about time. It has to use cesium. And then he said cesium decay instead of actually understanding what they're, anyway. If they're not measuring cesium decay. Sealion Prime says Mordwand equals murder wall. It's a reference to the north face of Eiger. Eiger is a mountain in Switzerland. Nordwand equals north wall. So many died on it, they named it Mordwand. So the north wall of Eiger, they renamed from Nordwall to Mordwall to be it was Murder Wall. So I don't know what that event was. Was that just people trying to climb the mountain, or was that a battle that happened there? If it's in Switzerland, probably people trying to climb it or search for it. I don't know what it was, but anyway. Lord Illuminous Pooh says in all caps. So he says, I am the dog of dyslexia. Fear my raft. I get it. Tim Davidson says, have a cop pull some light over and say, do you know how fast you were going? And if it was Spanish light, it would say, sí. Was that Lord Illuminous Pooh quality? Sealion Prime says, why did a cop pull over the super luminous spaceship? For violating the laws of Lorentz invariance. I don't know. I think Tim Davis's was a little better, Sealion, I gotta say. But I get it. Super luminous spaceship. All right. Sealion Prime says reification fallacy. They hate it. Yeah. So yeah. At Sealion, you were using the quantum eraser script on them. It was great. And the fact that they don't like QE, right? Witsit hates QE, but also totally bows to his prowess by still using the same scripts all the time. Oh my gosh. I just read this from Austin. Okay, now Alan and Shane should go ask them questions. They have just desperately searched for gotchas, then skated past all the answers to another 50 scattergun questions. So there's no desperate search for gotchas, and it wasn't 50 scattergun questions. This is very clear. They're talking about one thing. They're not searching for gotchas. They're saying, where did those muons come from? And no answers provided. Death blow. Astrokate Sathex says, anyone can download satellite orbital data to predict paths of satellites circling Earth. Using that math, you can track satellites with the telescope. And people do it. None of these people are flat earthers. Very nice, Astrokate. Yeah, I know Wolfie did some things with satellites as they got occulted by the Earth's shadow. So, all right, I am going to, you know what, I need to go grab something. So while I go grab something, I think you all need to enjoy a little bit of banjo music.
What is a full moon and what is a new moon on your model?
Probably like a magnetic cycle, and just like the center of a ferrocell image of a magnet.
I think it's probably like a magnetic cycle, just like the center of a ferrocell spiral. Image of a magnet, it's just black in the middle. It's actually pure inertia, not just a little. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. once more, and it goes back like it did before. Once it becomes like etherically spaced, you see it charge up and take its place. Oh shucks, ain't that so? That's how moon phases work, fam. Pass the dresser. In the magnet's heart, centrifugal divergence flies, centripetal convergence pulls. Defying all science, etheric whispers sing, light and shadow blend, magnetic cycles spin, where physics seems to end. In the ferrocell image of a magnet, it actually goes into its inertial state. Yeehaw! Then charges back up. It becomes like etherically displaced. Yeehaw! Grab your partner, swing 'em round, magnetic cycles up and down. Either song in the air, hillbilly science everywhere, 'cause it's like etherically displaced. Yeehaw! Yo, belly on up to the Wixit word salad buffet. Who has light vinaigrettes? Behind the Jugger Ranch.
Then charges back up, and once it becomes like etherically displaced again, you start to see it charge up throughout a cycle, and it goes back.
Oh, I hope that you've all become etherically displaced. All right. I had to top this off. Lord Illuminous Pooh says, stop saying it. If you say it 33 times, Latter-day Saints will show up. I don't know what he's talking about there. It was a little bit ago. Sealion Prime says, atmospheric Lorentz contraction. Grab the ranch. Atmospheric Lorentz contraction. Yeah. That was, Lorentz, Lorentz with Michelson Morley tried to propose, it was a hypothesis, perfectly fine, that the ether, the luminiferous ether, did have a physical impact on the object, right? He said that as the Earth orbited the sun, that as the Earth went into the ether, because they thought that the ether was stationary, and that the sun was stationary, that as it went into the ether, that the ether squished everything a little bit. And so Lorentz is like, oh, let me do the math. How much should it, in order to make it the squish the right amount, how much would it have to squish? Right? Based on the speed the Earth was moving and the amount, right? And all that. And he came up with the Lorentz contraction. The Lorentz gamma is the letter that we use in the math. And that was an attempt to say, well, okay, the apparatus actually squished, but there's no plausible mechanism for that happening, because why would things that are super rigid get squished and things that are not rigid get squished by the exact same amount? That doesn't make sense. There's no, right? If people are like, okay, well, yeah, cool idea, but it wouldn't happen. So everybody's like, okay, what else could it be? So, but yeah, atmospheric Lorentz contraction it's even worse. Sealion Prime says, muons were discovered in 1936. In 1940, the relativistic effects were discovered at Echo Lake and Denver, Colorado in 1940. Yeah, so they're not directly related to relativity. So they were desperate. Peachy Tony says, we can confirm the effects of time dilation and relativistic mass changes in completely controlled conditions in particle accelerators. Well, according to their live chat, particle accelerators don't even do anything. It's just a bunch of nothing. So again, denialism. Peter, who's on screen here. Peter the Globe Prover says, for $20, thank you for the awesome review, MC Toon. The glob lives another day. Oh, so happy the glob gets to live. All right, let's keep going here.
Suppose you have a moving train car at a velocity v full of passengers, and there's a bomb at the center of the train car. Bomb is configured in such a way that it'll detonate when it receives a simultaneous lightning strike at the front and the back of the train car. With respect to the train car, there's a stationary observer on a platform. At the exact moment that the bomb-carrying train car intersects with the stationary observer, lightning strikes the front and back of the train with the stationary observer. Does the bomb detonate, or is there a temporal divergence due to link contraction and time dilation as a function of the square of the velocity of the train over c? And are the passengers saved? What say you, sir?
Well, I think we need to get a little bit closer on some of those definitions there. Like, because we need to think about it. I think the distinction is going to be whether there's a relative frame or an absolute frame, correct? Do you agree that if we assume a relative frame with a constant speed of light, then it would follow that simultaneity is relative?
What was your question?
If we assume a constant speed of light in all reference frames and the principle of relativity within those frames, it would be the case that simultaneity would have to occur in relative fashion. So my question to you is, doesn't your understanding of this example for us hinge on whether or not there exists an absolute lab frame on Earth, and where would it exist relative to that moving train?
Would the bomb detonate, yes or no?
Well, I think we need to define the terms a little bit better.
Answer the question.
So if
define the terms and answer the question. They're your terms to define. You're the relativist.
That's what we're trying to do. So our position is in accordance with relativity, right? So
what does relativity say?
I have the answer on the screen, if I may, Sealion. Yeah, what is shown here, and there's a GIF, so bear with me because it's animated, but that's a good thing. From a position, let's say A and B denote three independent events, three bombs exploding. From the point of view of a stationary observer, V0, all three happen at the same time. You can see it right now. All of them are happening at the same time. An observer who's moving with a speed 0.3 sees, wait for it, C occur first, then B, then A. And this observer, the opposite. This is what
your argument is that the train would not blow up due to the velocity of the train.
I couldn't follow your description because you were speaking so fast that you lost me after the first two sentences.
Do it again.
Do you have a picture? Can you provide some kind of picture that you can walk us through
the point
step by
is,
step, like the way I walked you through the muon measurement?
Go to Google and type relativity train car.
No, I'm not going to Google. Okay. I want you to walk us through it.
Got you.
The point is, no amount of relativity makes that bomb not explode. That's the correct answer.
Yeah,
that's you can see all three events occur.
No matter where you're looking at it from, it goes boom, Peter. No matter where you're looking at it from, doesn't matter.
That is true. That is true.
Okay, so then there is an absolute frame.
No, all events occur. The three independent events, A, B, and C, occur in all frames of reference.
Then there's an absolute lab frame then.
No, clearly there isn't. The coordinates for the moving observer are rotated through the ether.
So your argument is...
Now, just for reference, there is no actual bomb that actually was done to test this. This is just a discussion about what the implications are of relativity and whatever they have, right? There's no bomb. There's no train. Don't worry. Nothing exploded.
That the bomb wouldn't detonate because of the velocity of the train.
Again, you have to walk me through your thought experiment step by step because your speech was incomprehensible to me.
Okay, well, you can go back and listen to it then on the playback. Here we're going to read. Here we're going to read back from the definition of simultaneity here, where he says, down at the bottom, we shall not here discuss the inexactitude which lurks in the concept of simultaneity for two events at approximately the same location, which can only be removed by abstraction, which is what you're doing right now, because we all know that.
I just want to remind everybody that shame is the one that demanded that everybody go back to empiricism and real experiments.
The train would blow up, which implies that there's an absolute frame for them all to be relative to. And the hypothesis of the ether theory is that all events will occur simultaneously in the ether. Guess where the ether's at? In the lab frame on Earth. Now, for the next part, you were saying...
Hold up a second. Let's pull him out a little bit. So
what's up?
You say that the
no.
This within an absolute frame
But before we move on, both of you guys...
That's important because you just slipped that in there. That's a very important point, though. We need to address that.
Okay, just write it down. Remember that. Go ahead.
Before we move on, both of you guys agree that the train blows up in all frames and the velocity of the train will not save anyone.
I don't, because I couldn't follow your experiment, your description of the thought experiment. You were speaking too fast.
Okay, how about Sealion Prime?
I concur with Peter.
You concur with Peter? Oh, all right, bro. We're going to run it one last time.
Yeah, walk us through it. Can you show us a picture? It's very hard to visualize these things purely based on speech.
Well, keep trying to stare at your picture and just think real hard that it won't explode. That's what you can.
Yeah.
That wouldn't be intellectually honest on my account.
It'll be perfectly honest.
Can you stop that share for me, Peter? Thanks.
Suppose you have a moving train car at some velocity full of passengers and there's a bomb at the center of the train car. The bomb is configured in such a way that it detonates if it receives simultaneous lightning strikes at the front and back, similar to the the standard example that they give for the moving train car and the stationary observer at the center. Right? With respect to the train, there's a stationary observer on a platform. At the exact moment the bomb-carrying train intersects with the stationary observer, lightning strikes the front and back of the train car. Okay? Does the bomb detonate, or is there a temporal divergence due to the velocity of the train?
Yes. I am familiar with that. It's a common, puzzle in relativity. And the solution is well known. I don't remember it.
That's a real shame. Sealion, you.
So what would this apply? So let's think about this for a second, because
it's impossible to solve it. It's impossible to solve it this way. You have to draw geometrically all the relationships, and it's actually given to students in universities to solve this particular conundrum. There's a very well-known solution. This is a debate tactic to throw at you something that it's complex, that has to be drawn and calculated using angles and lengths, and now it's presented in a verbal form, and it's impossible to explain it correctly unless you just did it on a piece of paper and just are reading off your notes. So this is a trap.
Didn't we make up the train bomb example, dude?
It's a basic question, and it even says here in Einstein's 1905 paper, we shall not here to discuss the inexactitude that lurks with the concept of simultaneity for two events at approximately the same place, which can only be removed by abstraction. Right?
So it's hard to think about these things because they're counterintuitive.
No, you guys all agreed that at one point that the bomb would go off, and then you stopped when you realized the implication of an absolute frame.
You're in the lab frame, right?
And then now you're appealing to an equation that doesn't exist. And I'm not even going to pick on you.
An equation that doesn't exist.
I'm not even going to pick on you and tell you to pull it up and show me right now. So I don't give a shit. I know the bomb blows up and
they're spiraling. So in special relativity, there's no such thing as violation of causality. And there's no such thing as events occurring or not occurring depending on the observer. This is very well known. And all the paradoxes in relativity that are given as thought experiments for people to calculate and compute, that is done every day in every university on Earth, have a known solution within the special relativity.
What's the solution for the muon paradox?
Gotcha. Okay.
I just provided it to you.
Yeah, we just talked about it. So
let me ask you this: Would you board the train then? Would you be on the bomb train and take the risk? No,
not without having first thought through the thought experiment. I would sit down for a few hours. I would think through the thought experiment. I would employ the services of a person who's familiar with these problems to help with my poor knowledge of geometry, and I would then answer your question.
Let me ask
would you get on the train?
Let me ask you about the implications of that question, though, because you mentioned
the implications are you die. Would you get on the train or not?
There's two things that are related to that question that get back to this idea of the absolute frame.
Borg Emporia says, do you realize it's almost 1 a.m. where you are? Yeah, 6 minutes. Why?
Far in the debate, we have not established a constructive difference between a theory of the ether and a theory of the relativity on the basis of what we established of our definition of ether. The only thing that will distinguish them on the basis of what we've talked about so far is the existence of an absolute frame. Now, there's two components that we need to talk about with relation to this supposed absolute frame. The first one is...
Oh, look at this one here. I'm not going to read his names. Flat Earth theory is about to take over very soon. They have run out of globe fence. Seriously. Every single day, not every day, but ever since I started watching these Flat Earth clowns, they've been saying that. We're right on the cusp. We're about to take over. Everybody's about to figure it out. But it never happens. You know why? Because you can't answer one damn thing about Flat Earth. What time will the sun set tomorrow? You don't know. You know nothing. How high is the sun? You don't know. What's the how much of a building should be obstructed if it's 10 miles away and the observer is 6 feet above the surface of the water? You don't know. You got nothing. All you have is, it looks flat, bro. And cool story, bro. Seriously, flatties, you got nothing. You got nothing. And when Sealion and when Lucas and Peter, when they're like, what is the explanation for these muons that you're trying to away? You don't know. You have nothing. I think they just pop into existence. From where? I don't know. Then you lose. Then you're right. You don't have anything. It's just a religion. Then you believe it with no evidence. That's a religion, right? It's fine to have a religion. Lots of people have religions. But having a religion about a physical thing, about physical reality, well, that's weird. Especially when it contradicts physical reality, or you have no reason to support it, right? We've got a whole bunch of explanation for physical reality here that doesn't require blind faith. You're like, nah, I'm going to take this whole bunch of things for physical reality here that has absolutely no evidence for it on blind faith. So reject the actual stuff on blind faith and accept the non-existent stuff on blind faith. That's ridiculous. I mean, that's not a traditional religion. Traditional religion where it's about the afterlife or about spiritual realm or about morality, right? Whole different thing. But it's still a religion. And I'd say that one is completely insane. All right. We've got Kango 44 for 20 Kiwi bucks. Says, for the lightning point of view, it hits first. From the people on the train, the event happened next. And for the people on the station, they see the train blow up last. Clowns think it actually happens at different times. I'm not like Peter said here. I'm not up to date on that particular problem, and like Peter said, I would employ the services of somebody that has a deeper understanding of it. So I'm not that person, not today. Would it be interesting to have somebody come on and go through that and apply relativity to it? I think it would. If you are that somebody or know that somebody, and if you think it'd be interesting, contact me and let me know. On my website, mc2.net/contact, I think. Anyway, there's a contact link. If you don't know how to get a hold of me, that's how to get a hold of me. PhD Tony says, would I get on the train? That depends. Would getting on the train end my interaction with Alan? Oh, yeah. I get you there. but it might blow up. Doesn't matter. As long as the interaction with Halon stops.
We've identified that unless you have another piece of evidence you want to discuss, your only piece of evidence for a one-way speed of light calculated within this absolute frame of reference was from GPS, which by itself would require calculations and adjustments by your own admittance. So I don't see how that's compatible with an absolute model of an absolute frame. But the other question I have for you is, you mentioned that the ether is within that frame. Can you expand on that piece specifically? You said the ether is within the absolute frame.
Before we get there, I think for Adam in the chat, who said devil signatures on globe theory, I don't know why he said that. Maybe it's because of all of the 666s that he imagines exist, but really those 666s are all over flat Earth theory. Why is it on the flat Earth that there's 66.6 degrees of latitude from the North Pole to the Tropic of Cancer? Why is that, Adam? Adam, why is this 666 in flat Earth theory? Is it because the devil made it up, Adam? And Adam, the sun moves 1,666 kilometers per hour as it circles the North Pole, or miles per hour. Sorry. Is that a coincidence? I think not. Obviously, Adam, the devil made flat Earth. No. If you want, you can mangle 666 out of anything you want. You pick a number, you can force it out of anything. If you think that's real, you're stupid. And Adam, you're a flat earther. So by definition, you're stupid. Congratulations. You admitted to being stupid. Seriously, Adam, I just from the bottom of my heart, I want you to know, I mean this with all sincerity. Like just really just when I think, what do I really think about Adam the flat earther? Like what's in my heart about Adam? The answer to that question is that you're stupid. That's what it is, Adam. And the reason why, Adam, is because you think the Earth is flat, even though it's geometrically impossible for the sun to set on flat Earth. So, I mean, look at that there. Look at that, right? If the sun's above that little pizza thing there, there's never anything between the observer, no matter where they are, and the sun. Never. And if you don't understand that little thing, it's because you're stupid, right? It really is, Adam. Just really deep down, I want you to really know you're stupid. And when in school, people, your teachers are like, oh, that's a really smart question, Adam. They said that because they were trying to be nice to you, right? Teachers, they more than, in ages past, in ages past, they might put a dunce cap on somebody like Adam and make him sit in the corner and face the corner, think about why he's stupid, to try to shame him into not being stupid. I don't think that worked. But the nice thing about that is that the stupid people knew they were stupid. They were told, hey, you're stupid. But now we've done away with that. And people like Adam can get all the way through, whatever, education he quit at, and never really understand and comprehend that Adam, you're stupid, right? The teachers didn't probably tell you that, but it's good to know your limitations. I think it's important to know, Adam, that you're stupid, right? That the fact that the geometry, the very, very simple geometry, things that children understand, of the sun could never set if the earth were flat. That's very, very basic geometry. You don't understand that. It's because, one more time, Adam, you're stupid. Also, Adam, flat earth is satanic because I found 666s in it. That's your standard of evidence, though, right? Not mine. Yours. Okay. Let's move on.
Yes.
Okay.
There's a translation of motion that comes from the sky that follows sidereal time. This is measured with interferometry. As you increase in altitude, you measure a faster velocity, right? So in the same... What according to what? What do you mean?
What experiment has measured that?
Oh, Yuri Galev, Dayton Miller, and Picard.
Yeah, but I already provided you. I provided you with an alternative explanation for the Dayton Miller experiment.
Oh, yeah. So your alternative explanation is invalid. The Sagnac effect has no relativistic derivation.
That's a completely false statement. Would you like me to provide you? Would you like me to provide you with multiple statements to show that that's an incorrect statement?
Yes.
Okay, great. So let me go ahead. I have some sources right here. Let me
he
pull
said
that up for
Picard.
You.
He said Picard.
So there's the original derivation, and then there is. So you're familiar with the history of the Sagnac effect and its interpretation in relativity, right?
Are you sharing? We don't see anything.
I'm about to share now. Okay. Sorry. Sorry.
Who is Yuri Galev?
Dude with an interferometer.
Oh, such a helpful person Shame is. Once again, Mormon drink if he adds value, and Mormons are safe.
So here's a paper right here. The Sagnac effect and its interpretation by Paul Langevin. Langevin, sorry.
Yes.
Okay, so what is your criticism of the derivation in this paper?
Let's see. So relativity theory doesn't predict a fringe. That's my criticism. You can't hold on one second. Yes, yeah. You can't predict a fringe pattern without invoking a preferred frame at the center of the device. Relativity theory.
Show that to be the case.
That has nothing to do with it. That's ridiculous. And back to this right here. He's like, you have to have a point in the center of the device. No, you don't. It has nothing to do with the coordinate system, right? He says he's just asserting that you have to have a coordinate system. You don't. That it has to somehow be fixed. It doesn't. It's because while the device was moving, one of the paths got longer than the other path. It was a larger distance. There's no absolute reference frame needed there. One of the paths was longer. That's why it took longer. It's asinine that he says that.
Any sort of paper or result? How are you measuring that? What do you define as a fringe?
That's how Paul Langevin derived it, right? You invoke a geometrically convenient position at the center of the device for the motion to be relative.
In the derivation, walk me through where that happens, because that's an affirmative claim. Now you're saying that this is an invalid representation of the phenomena, and I can pull up a large number, if my computer will cooperate with me. I have a large number of papers here.
So a large number.
Yeah, I mean, I'm learning from the best. You guys have good papers, so I got to keep up. You know what I mean?
Dude, how come every question is you ask us 6 more questions and don't answer any of our questions? Right. How come we have to answer all your scattergun bullshit?
It's fine. Because you're making a strong affirmative claim on this absolute reference frame, and thus far.
So listen. I got you. Here we go. So this is the Dufour and Prunet Sagnac experiment that they did, right?
Yeah. Let's take a look.
This is their configuration they had here. Okay.
Oh, you're showing your screen. Sorry.
Yeah, I'm going to explain it should be sharing, right? Okay. Now, here's Paul Langevin trying to explain it through using general relativity. Right?
I don't see it. I just scroll some stuff on,
Yeah, I got to stop my screen share, I think.
Yeah, watch my web.
You already have it. Yeah, okay.
We can do that too, pretty much.
Okay, so this is their apparatus. They had
I cannot resolve anything in that small thing. You need to show it.
Click on it.
click on it and make me the center.
Yeah, I put it on the screen.
Well, it's still just.
I'm just curious. Okay,
It's still blurry, just so you know. I don't know why Alan's. Well, when you screen share, I know why. Alan isn't screen sharing. This is his video feeds, right? So he's fed his browser, his desktop. His desktop is being fed into the what he's sending in his video feed. So his video feed through Zoom is lower resolution, I think, than if you share a screen through Zoom. That's why it's not such high resolution. It's still blurry.
talk through this. So
Okay, let me talk for a second then. Instead
Yeah,
of you
absolutely.
half talking for me. Okay, so the Sagnac effect here, right? They had this experiment where they have a rotating table and they have a stationary table on top of it. They're using angled 45-degree mirrors and a source that's stuck to the wall on the lab, and a detector that's stuck to the wall on the lab. The source emits light, hits the prisms, gets split through the beams, and then it hits the rotating frame, and then it ends up back at the wall in the lab, right? Now, relativity.
Now, just for reference, the light path was changed. That's on a table that's rotating, and the path that the light took, one direction was longer than the other direction.
To explain this experiment, specifically Paul Langevin, and he comes in to say, after making the wrong prediction, right? He says, the relativistic theory thus seems to be in complete dissension with the classical theory and also with the results provided by experiment. But given that Paul Langevin appeared to allow the value to be reportedly higher, we considered that the center where the theoretical relativist must be presumably placed at the must be arbitrarily selected. And the relativistic theory found this contrary to the agreement with the classical experiment. This experiment, if the center is obligatory collinear with the center axis of rotation of the disk, this only point on the disk, which it can be a permanent origin of Galilean axis.
Oh my gosh, Witzitt's projection. just read his projection there. I'm not gonna read it. Go ahead, read it yourself. So much.
Subjected to rotational moment. This is despite the explanation Mr. Langevin said to us when he arrived after being informed of the results of our experiment. So Paul Langevin was saying that he could derive this, no problem as a relativistic effect, and he could only do it invoking a preferred frame at the central axis. When you set up for a Lorentz transformation, here we go with, let's see, what was his name? Artiglia. Artiglia does the exact same thing to try and address the Sagnac effect. There is no frame that predicts the amount of fringes in relativity theory unless you invoke a preferred frame. One second, where's mine? What am I looking for? Artiglia.
So in the chat, we've got where did it? Look at it. So you can see a little more. We've got Adam in the chat here, right? Everybody, just Adam is a brand new Flurf. It seems he's going through the Flurf, the introductory Flurf packet when he went to Flurf summer camp this summer. He just got back a little bit ago, and he's like leafing through the pamphlet, and he's in here typing in the things that are from. He's like, oh, let me. Earth is 70% water, and water is flat. Chess mate. Yeah, good job, Adam. Remember, you're dumb. Remember, I want you to remember in your head. Get this in your head, Adam. You think the Earth is flat because you're dumb. Okay, that's how you got to where you are right now. There it is. Seawater is level. Sea level is water finding its level. Oh my gosh. It's like, it's just so dumb. You're just like you're just parroting. Like you don't realize that you're just a parrot. Here is the definition of level. Merriam-Webster. Put in the chat here. Here you go. Dumb Adam. So dumb. Poor Adam. Anyway, definition of level when referencing the surface of the Earth. We need to find the right definition, and we're talking about an adjective because it's descriptive, right? It's not a noun. This is a noun. This is level for as a noun, right? Level is a noun, right? Not, and it's not a verb. The verb would be to use this to make something level, right? That we're talking about the adjective, the description of something. So let's go to the adjective right here. Here it is. Having no part higher than another, conforming to the curvature of the liquid parts of Earth's surface. Adam, you're stupid. When you parroted like a good little indoctrinated stupid person, you said sea level is water finding its curvature of the liquid parts of this Earth's surface. Yep. If water finds its curvature and the Earth is 70% water, how does the Earth magically turn into a globe? Because water is curved. The surface of water is curved, as is the definition of level. So, and then he's like, wake up. Hey, yeah, wake up. You just said water or the Earth is curved. You just said 70% of the surface of the Earth is curved. You're dumb. That's it. You're dumb. You're stupid. You're an idiot. Right? That's it. I mean, it's there's no... You're just an indoctrinated parrot, right? You don't have a clue. Here you go. Here's from a book published in 1814. It's the theory and practice of surveying, containing all the instructions requisite for the skillful practice of the art. But the original, this isn't even the, it's a second, third, fourth, fifth edition of the book. First edition of the book was in the 1700s. Leveling, right here. We got the true level is the curve conforming to the surface of the Earth as ABG. On this little graph here, we've got ABG, the curving ABG, the curve ABG, right? Right. That there's no end to, look at this here. That curving line, you see where it says over on the right? It says level line over on the right. Level line. It's level is a curve. Right? So if you're like what you want to say, let me just give you a little hint, right? Instead of parroting your Papa Flurf, who told you that, right? You want to say is your claim is that the surface of water is flat. So I'm just helping you. You want to say when you type it, water seeks its flat, not water seeks its curve. Curve level. Level means curved when referring to the surface of the Earth, right? You don't get to pick the definition that people use for it, right? If you say that, you're saying it's curved. Your claim is that it's flat. Just helping you, just trying to help you. So water seeks its flat, okay? And then the next step would be for you to get measurements of the flatness. And that's going to be a little challenging because there are no measurements of flatness of water. Sorry, buddy. Just so you know, just for reference, if you're like, the water in a bathtub is not curved. Well, how much curve does the globe suggest there would be in a bathtub? You don't even know that. So how could you even test that? And also, measurements have numbers. Measurements have numbers. Let me say it again. Measurements have numbers. Also, they have units. You don't know what units are. When I say that, that's a mystery to you. Units would be something like meters. Meters. That's a length. It's a unit of length, meter. And so if you wanted to find a measurement of flatness, what you do is you'd say, well, we established a flat reference somehow. I don't know how. It's on you. We established a flat reference, and then we measured the deviation, the difference between that flat reference and the surface of water at different distances away, right? So you set up right at one end of a body of water at a certain elevation above. You say, well, let's get 5 feet above it, and we'll put an instrument 5 feet above it, right on 5 feet, and then we're going to take something and we're going to go a mile away. We're going to put a target 5 feet above it, right? And then we're going to sight through the one to the other, right? We're going to use some instrument that is able to determine whether or not it's angling up or angling down or angling straight. These devices exist. And then you look at that distant object and you say, well, does that distant object line up, right? Does it go up or down or stay the same at a mile away? Now, I know, because you're dumb, Adam, this probably just went over your head, but that would be what you'd need to do, and it's not been done. So, anyway, Adam, just let you stew and you're dumb. Let's keep going here.
1 second. Here we go, Tartiglia. So, what they do is they set up for a geometrically convenient position here, right? Oops, the frame's a little messed up, or the picture's a little oversized, but you guys get the gist of it. The world line is noted here in the center axis of the rotating device for the fictitious frame, and then the deviation here is the rotation for an observer at the rim of the device. This is how the relativist explains the Sagnac effect, right? By invoking a geometrically convenient position, always. This can't be answered with the Sagnac equation, or like it can be with the Sagnac equation. You have to invoke a preferred frame. Now, when you get into the derivations for the Sagnac effect as a relativist, you will find, second, nope. We're getting close. You feel it?
I do.
All right, 1 second. Right here. So here's relativity, right? Assuming a constancy of the speed of light for the two observers, right? So we have a source and a recorder on a platform that's rotating, right? You agree? The Sagnac effect, classic Sagnac apparatus setup, observer recorder on a platform that's rotating. Okay. Yep. Uniformly rotating. Relativity predicts that they're an inertial frame, so C will be measured as C for both of those people, right? So if you math that out, what you're going to get is C going clockwise and C going counterclockwise will be the same speed, which will produce no fringe shift pattern.
No.
There's no way to explain this without.
No. It's a different distance, one direction than the other. Oh my gosh.
Invoking the geometrically convenient position and doing a Lorentz transformation. That was shown by Tartiglia here. Sorry,
go ahead. My bad.
Sorry, this was shown by Tartiglia here, where you can only explain the Sagnac through geometrically convenient positions. Now earlier we were talking about Michelson, Gale, Pearson and whatnot, right? So we have...
So Michelson, Gale, Pearson, or Michelson, Gale, Pearson, is a seminal interferometer right here. This type of apparatus right here. Light went different ways around and got recombined at the other end. That's Michelson, Gale, Pearson, often just called Michelson, Gale. Not Pearson. Pearson wasn't very much involved, but at the time he was a well-respected scientist, so they invited him, and it got a little more notoriety because he was had a little more street cred. But from what I've seen, Pearson didn't do much. So anyways, typically just Michelson, Gale.
Hold on, let's before we go there though. I think there's important. What do you mean by geometrically convenient?
At the center of the device where it's stationary and non-rotating.
Okay, but what is the issue with that?
It's a preferred frame, and relativity can't derive a solution without invoking it, because relativity.
So Clive Wells is saying a rotating frame is not inertial. That's correct. It's because it's rotating, it has an acceleration, right?
Contradiction.
Relativity predicts that. So let's assume that link contraction and time dilation would apply to the apparatus. The fringe shift pattern that relativity would predict would be much smaller than the one that's measured, right? Because the velocity is a one-to-one relationship, whereas relativity predicts that the fringe shift would be the square of the velocity over c squared, which would be much smaller than what's predicted.
Can you show that derivation specifically?
Yeah, that's link contraction and time dilation, right?
Okay.
That's the square of the function of the velocity.
So it's a discrepancy.
Yeah. So I'm still not understanding how this creates a preferred frame.
The discrepancy is relativity predicts a much smaller fringe, and it can't do it. Right?
It can't do it.
What?
But that's just a statement you're making.
No, it's actually shown here in Tartaglia's paper with the geometrically convenient position that he had to invoke to try and explain it. And then he had to do the same thing for Ruyang Wang's experiment. Right? He had to invoke a geometrically convenient position in the center of that as well. Like you guys want to see some geometrically convenient positions real quick? Check this out.
Oh my gosh. The idiot in chat with his introductory flurf packet. Can you believe? I mean, seriously. How dumb do you have to be, Adam? I mean, you are so stupid. You are so stupid, Adam. Right? I am being nice to you by calling you stupid. Right? This is not an insult to call you stupid. This is an assessment of your intelligence. You are stupid. So Adam said, proving that he's stupid, P1000 cameras bring boats back into view. So how does Earth curve if these boats were three all along? He meant there. Well, just for reference, this camera right here, is a P1000. It's mounted above my desk. That camera is a P1000. You can actually see right here. Here comes. Watch it. Here comes the lens of it. There it is. There's the P1000. So I've got a P1000. That thing you just talked about, I've tested. It's not true. You are gullible and easily indoctrinated. All right. Here we go. I will for right now. I'll give it to you right now. Brings boats back into view. Let's test your claim right now with a P1000. You're gonna love this. You're gonna love this. So here we go. And by love, I mean run away from because you're dumb. So all right, let's get. Here we go. Took this picture myself with the P1000. Right there. You see that? Out there? You see that little not over on the right side. The one right in the middle of the frame there. Got some crap in my eye here. See that? That's a boat. That's the P1000 zoomed out. You see that boat? So now according to what you just said, parroting somebody without having any knowledge of it, said, well, if I increase the zoom, then I will see more of that boat. I increased the zoom. I just zoomed in. That's all this was. This was a zoom in. I saw it's the same amount of the boat. The same amount. Oh no. Let's zoom in more. Maybe that's not enough. Uh-oh, I zoomed in all the way. The same amount of the boat is there. Zoom did not change how much of the boat was visible. Your flat earth God lied to you, Adam, and you were dumb enough to believe it. Oh, Adam, you're stupid. I tested it myself with a P1000. So Adam, now do you know that you're stupid? You should. You should know. It's important for you to know, right? If you didn't know you're stupid, then you would go around thinking you're smart. That would be silly.
Not necessarily.
Linearize it, generalize it.
Where's our boy? So this is Bard 2022 trying to explain the Ruyang Wang and the Sagnac effect as a relativist. And here we're going to look at, he's going through a thought experiment. He's breaking it down, realizes that even with the gamma factor, there's no ability to explain it. And he goes on to say, though the mathematically it is fine, but the physical understanding of the effect from the standpoint of an observer attending the rotation remains difficult. Why is that? Because relativity predicts no fringe shift pattern.
No, it doesn't.
We have Post in,
why?
What was it? Post in, what was it, 1967? Right, we're going to read a comment from Post. 1967, to be consistent with the principles of relativity, one has to demand that the Sagnac interferometer ring laser cannot lead to a fringe shift or a beat frequency
Why?
if the equipment is in uniform translational motion. And then obviously this is a direct contradiction.
Translational versus rotational? I don't know what that reference is. Translation usually means a side-to-side movement, right? Versus a rotational movement. Yes, if the interferometer is in and I don't know what this reference is, so I don't know the context of it, but that word translational instead of rotational tells me something. I don't know, Sealion or Peter or Lucas, is that anything? Am I on to anything there?
Now, Einstein says that his equations apply in a curve where it's uniformly, or any polygonal circuit that's in uniform rotation. So if you continuously do a curve, that's a circle, and if it's in uniform translatory rotation motion, then his equations should apply, and the fringe shift pattern would either be no fringe shift pattern, or it would be much less than the velocity of the fringe shift pattern.
When is the latest paper that you're citing on this topic as it relates?
2022.
Okay, perfect. So I have here another paper that seems to contradict what you're saying, and I'm not understanding the source of the contradiction. So this paper presents a relativistic explanation based purely on special relativity that describes the fringe shift that you're talking about. So is this then required? So there are two things tied up in this. I think you said that there's a preferred reference frame set by a geometrically convenient position. But I also know of another paper where they have a sort of more general approach to the Sagnac effect, where there's a basically.
All right, Adam here, one more time, says, I'm not calling anyone dumb or stupid. I know that's because you're the dumb one. I'm just simply shining some light in here because it's so dark. Yeah. Dark as in evil. And his flat earth is lightness. But Adam, I proved that you lied. Adam, I proved that you lied. You made claims about the P1000 zooming in on things. And then I proved that it doesn't happen. So you told a lie. You probably believed it, but you still told a lie. And Adam, who is the father of lies? Who is the father? Who is that? And in the light darkness realm, which one is the father of lies? The light or the dark? He's the dark. Adam, you're lying. You're propagating lies. You're not on the side of light. Keep that in your mind. You're also dumb.
Difference in the way that the loop is centered, and they're still able to define their effect relativistically. So I'm not sure that is required for this.
It's absolutely required. I'm sorry.
Well, why is it required?
If the speed of light is constant and you're in uniform motion, you measure C as C, and you measure it because of link contraction and time dilation in the moving frame. So if you're in uniform transitory motion, relativity predicts that C will be C, and if C is C, then it's going to complete the circuit at the speed, and there's going to be no fringe shift pattern. It's going to combine at the same time, but there's not.
But this paper is directly contradicting what you're saying. So, I mean, obviously, I'm putting you on the spot to speculate on this. We could read this paper more in detail at a later time. I just don't know that this is an accurate statement of how special relativity approaches this problem. And then I kind of going back to this, the implication of this would be what? A non-constant speed of light in an absolute reference frame or a preferred reference frame? What would be the implication of what you're saying about the Sagnac effect? Because I just based on just the papers that I've read, and I'm citing one in particular right here, that what you're saying is not correct.
The implication is that all velocity is measured with respect to the ether.
Okay, and the ether, you said, is within your absolute lab frame.
Yep.
So, okay, let's dig into that. But there's also an ether wind.
Well, let's stick with the Sagnac and the derivation.
Yeah. But I'm trying to understand the Sagnac effect in relation to the ether, because that's the distinction.
You're explaining it with a rotation, right? That's what this paper is saying, and that you're ignoring the linearization and generalization aspect of it completely. Is that where we're at?
No, and that's not what I'm saying. So when it comes to the Ruang Yang and the linearization, that's an attempt to apply a different interpretation. But I can also show you a paper. It's an attempt to apply a different interpretation to the Sagnac effect, one that has never been empirically demonstrated.
He did it 3 times. Did it 3 times.
So let's. I have a direct paper that speaks to. I have it right here. I have a paper that speaks to specifically the issues. This is.
It's not a rotational effect, so using a rotational frame to describe it is kind of silly, right? Is that your argument?
It is a rotational effect, as a matter.
Of course not. That's what Ruang Wang proved in 2001.
No, he didn't actually prove it. So when you look at the actual derivation here, and this is also kind of strange because you seem to have imposed this arbitrary standard on us that we can't use certain forms of mathematics. But now what you're saying is, well, this person did a certain transformation and seemed to suggest that rotation could become linear. And what I'm telling you is that this paper right here, which I have a copy of, I can certainly send to you, and this is from Spavieri et al. It basically goes through, and I have the DOI, I can send you the citation. It essentially shows that Ruang Wang essentially was just basically doing what you accused us of, which was some sort of mathematical trickery. And that's supported by the fact, no, that is correct. And it's supported by the fact that there's never been, would you agree that there has never been demonstrated a device based on the linear Sagnac effect to measure linear motion in that way?
He has a patent for it, doesn't he, Alan? But anyway, the point is...
he has a patent for it. Oh, therefore what? Wow. Once again, drink every time shame says something useful. Mormons are safe. Having a patent for something. This is they like to bring that up. So I'm on a couple patents. One granted, a couple applied. I've been through some process. In fact, the patent I'm on has expired, but when it wasn't expired, the startup I was at was trying to license it or sell it or something. We flew out to Boston, met with IBM. I thought it was a silly idea. I didn't think the patent was all that great, but whatever. As the CTO, I'm like, all right, well, let's go. So we went to Boston. We talked to IBM to try to sell them the patent. They weren't interested in the end. But I'm a bit familiar with the process of patents. The deal is with patents is you patent an invention, just an idea. It does not need to physically exist, right? You don't. Part of the patent process isn't showing that it works. The patent process is showing that it is unique, that it's not already been created and patented by somebody else, and that if it's similar to some previous patented object or idea, that it is unique enough from that previous one. So that's all that the patent process is doing. You can patent anything as long as you can show that it's novel. That's it. Doesn't have to work. And shame is like, oh, it was patented. So what? It doesn't mean anything that it was patented. But shame and Alan never having done anything in that field and having no idea how patents work, and having basically nothing technical that they've ever done that they're accountable for, right? If you use physics to design a bridge or a building, then you're accountable to it, right? Because if you didn't do it right, there will be a failure potentially, right? The bridge, it could fall, people could die. I live in Minneapolis area. The 35W bridge collapsed. There were issues with it. People died because of that, because there was a failure in that bridge, right? They think that the flaw was that they were doing some work on it, and that they were storing material on it, and that like tons and tons and tons of gravel and rocks and stuff, concrete, whatever. So Icy Spin, would you say that technically they've never done anything? Yes, technically. Nothing. They've never done anything technical. Yes, all of these things are talking about outside their comprehension, and they've never done anything. So, what's Adam up to now? Let's see. Could I patent a flat Earth? A flat Earth is not an invention. You have to patent an invention. You're not even smart enough to understand what a patent is, what an invention is. Gosh. Oh my gosh. It's just so dumb. How do you survive day to day, Adam? Poor guy. Just such a dumb little moron.
That's not what I asked you. There's plenty of patents out there that don't lead to
anything. You said that it's not a rotational effect. It absolutely is. And
oh, wrong Adam. Okay, I'll take that as sarcasm. Adam Hymus. All right, I'll look at right here. This is the one. Could I patent a flat Earth? Adam Hymus said that. Right there. This one. So yeah, sorry, Adam Hymus. That was it. That was not it. I lived my best life. It's almost, out of shame, Adam Hymus might change his name.
Linearized, meaning that the travel time difference is proportional to the area enclosed by the path of the angular velocity of the rotation, right? Well, hold on, dude, right? Hold on. You've been talking an awful lot, right? What are you getting scared for? It's all right. So, like, when you're saying that it's not a rotational effect, and then we're saying that it actually is observed in a linear system.
Can you mute your mic while he's talking?
Yeah, just mute, please.
Sorry,
We're saying that it is observed in a linear system. That's what Ruang Wang proved with his paper. That's what the mathematical formula is derived from, right? It can be, by the fact that it can be derived, negates your position. By assuming that light travels in relation to a fixed laboratory frame, that is the whole point. Without that, they wouldn't be able to do this. This is, in fact, the direct contradiction to your supposed paper explaining the Sagnac effect with yet another rotational system. What do you think, Alan?
Here's the problem, though. Here's the problem with that, because I can provide another paper which specifically critiques the methodology of Wang and proves that all he did was reset the coordinate system in a way that made it look linear, and that's supported empirically by the fact that there has been no device ever produced.
Notwithstanding,
do you understand how revolutionary this technology would be if what you're saying is true?
What was the shape of his interferometry?
Hey, Sealion,
right here.
What did it look like?
We're still within our time, right?
Come on, Peter. What did it look like?
You both have about 15 minutes left.
Okay. I have an idea how to get us out of this conversation. I'm worried that the audience might be asleep at this point. The Sagnac effect is, it is my favorite topic, but may not be everybody's favorite topic. So what I would like to say is this. We all agree that the human intuition is that there should be an absolute reference frame. We have presented a case that through empirical study of nature, people have arrived at the conclusion that an absolute reference frame does not exist. And when you look at the Sagnac effect, and you look at the explanations that are supportive of special relativity, they consistently explain that effect. It is a difficult effect, and it's to explain, and it's normal that many people are confused by it. I'm sure our audience is. If you've ever gone to took a course on relativity, they threw at you different mind-bending problems to solve, and when I did that, I often got them wrong. But when someone told me where I got them wrong, it became obvious to me why they were correct and I was wrong, because I could think through them with their help. What you're showing, Alan, is a number of papers by other people who are trying to wrap their heads around the Sagnac effect, and they took a specific position, and they thought it broke special relativity. What Sealion is showing is another set of papers that are completely consistent, provide consistent explanation with special relativity. Trust me, the four of us are not going to solve this here because these are difficult problems. But what you're presenting as some kind of conclusive evidence that special relativity is broken is countered by Sealion's equally valued evidence that they're not. And I would wager that those have more support in the physics community than yours. I would still like to know who Yuri Goliath is.
And the other question... Sorry, go ahead.
You're good, go ahead.
Yeah, so I mean, I think the other thing that we need to focus on that's really specific here is that we have not been able to narrow down if there exists an absolute reference frame. Your claim has been that we can therefore measure the one-way speed of light, and you claim that we did it with GPS, and that's clearly not within the context of an experiment. So do you have another experiment that suggests the measurement within an absolute lab frame of a one-way speed of light?
Not off the top of my head.
Okay, do you see why that's a problem?
No.
Okay,
You see why it's a problem that relativity theory can't predict a friendship pattern without invoking an absolute frame? You understand that?
No.
Do you understand
No.
that? Why neither?
He just showed you that it can.
Stop. Not without a geometrically convenient position, dude. You want to see what relativity predicts for two observers in uniform transitory motion? It predicts no fringe. Okay, when I read that guy,
guys, can you just let him finish? He's letting you guys talk.
When I read that guy's paper, I'll find the geometrically convenient position for the transformation that's in there. Okay, because relativity doesn't predict a fringe shift pattern. Now, number two, let's see, where was I at before you interrupted me? The Ruyong Wong's device, you talking about a coordinate system obfuscation or something like that? That's retarded. The fringe shift pattern is derived here based off of the delta. Sorry. You're right. The delta L is the effective length of the apparatus right here, just the part that's in the motion. So when he did the parallelogram configuration where it's just the top linear portion, that's the only portion that it's measured with. So with respect to what is 4 pi velocity delta L over c lambda, with respect to what is that measurement made to? If it's a linear device.
Well, I dispute that it is actually a linear.
Gosh. Adam playing word games. Airplane travel through the air over the plane. Sea level. The seas always find level. Hence the words airplane and the sea level. Don't overcomplicate them. That's how stupid he is. Right? You have to seriously have an IQ of, just at the very bottom to think that the words airplane and sea level force the shape of the earth to comply with those words, like his particular selected definitions of those words. No, they don't. You're stupid. You're dumb. That's how stupid flat earthers are. Adam is demonstrating for all of us in real time how stupid flat earthers are. Right? That's why I love it when they come here and they say the stupid things they say. Right? Because it shows, it puts on display how stupid they are. Right? You are an embarrassment to your family. Right? And if the pattern holds, you don't get along with your family, Thanksgiving isn't a good time for you. Right? Your close relatives, your siblings are ashamed of you. They don't talk to you much. And if I were to call them up and say, what do you think of Adam? They'd be like, yeah, that guy, we lost him. He's gone. We can't even have a conversation with him anymore. That's you, Adam. If you follow the pattern, right? It's very sad. Right. But if you're going to play word games, well, the airplane flies through the atmosphere. You see, it doesn't change anything. That's how juvenile it is. Oh, I didn't mean to do that. I meant to do this.
And the reason that I dispute the reason I dispute that is twofold. I have a paper that, I see it, but I don't just simply believe a paper on its face. I need to think about it within the proper context. So what you're describing is completely at odds with all other characterizations of the Sagnac effect, and would be so revolutionary as to create an entirely new class of devices. So I find it difficult to believe that this paper is accurately presenting what it's claiming to present, particularly in light of not seeing a physical apparatus, not seeing the full data set, and having another paper right here, which I can provide to you, which breaks down the definitional problems and problems with the way that this experiment was set up that invalidate it. So I'll ask you again, what evidence is there that an effect that would be worthy of a Nobel Prize has ever been implemented outside of this claimed lab frame?
Oh, he patented his work, and then right now there's 3 companies that have patents on similar devices. Now there's nothing in production. Now there's nothing available for commercial use or whatever. But let's say that
the reason why there's nothing available for commercial use is because their claims don't actually work. You can patent something that won't work, but you can't build it and sell it very successfully if it won't work, unless it's on Temu. Then you could sell something that doesn't work. Or Wish.com.
device did, work as intended, right? He got the equipment on loan from the military, right? And he patented it. This is the second experiment that he did. After the first experiment, he filed for the patents for everything, and then he did this one, right? Now, if they're using this or whatever, it would be, classified because they're using this for military tech.
So an existence of a patent is not empirical evidence or a scientific claim.
You asked if anyone had a device. You said there was a patent.
The answer is no.
Agree.
Just say no, and let's move on.
Let me ask another question, though, because it's really important.
How about you answer a question?
Yeah, I've answered plenty of questions. So I think the next thing I wanted to get to, though, that's really important is, again, we have not had a constructive difference between the ether as we've contextualized it. We've provided, nothing but evidence that our conception of ether within the framework of Einstein, and I can provide you with many other papers. So, for example, there's the paper from Jacobson and Mattingly in 2000 that define a fully compatible theory of general relativity based on a dynamical unit time-like vector field, which they call the Aether, which fits all of our definitions and all of the ways that we've contextualized it. So your only distinction of your ether and our ether and which theory should be preferred in this context is the existence of an absolute frame and the ability to measure an etheric wind that explains these interferometer effects. Do you agree that that's true?
No, neither of you agreed to get on the train with a bomb, so there's an absolute frame.
That's not a fair argument.
So let's think about that.
Then tell us you would get on the train then. Tell us you'd get on the train then, dog.
Tell us why you won't.
I'm already on the train. I'm on the train already.
I got 2 train tickets. Both of you guys want them?
That's a fun little thought experiment, but it would imply that an absolute frame exists in the I refusing
So you're refusing to answer on the ground that I'm
personally...
Moderator, a direct question was asked.
Yes, I am answering the question.
Thank you.
I am already on this train.
Got you. And then Sealion. You're just going to be sarcastic? You're not going to
join me on the train, Sealion. Join me.
No, yeah. So I think at the end of the day, what we're trying to get to in this thought experiment is the existence of an absolute frame. So
on the train unless you're afraid.
Your claim that such a frame must exist on the basis of this thought experiment is not demonstrated by any empirical experiment you can provide in which we can do a measurement of the one-way speed of light in an absolute frame.
That's a lot of words for you're afraid of.
I'd like to make a comment to the audience, please. I remember 20 years ago solving that particular puzzle in Relativity. I got it wrong. I struggled for hours to understand the correct explanation. I had to go line by line, angles, lines, relationship between all of it, and I understood the solution.
You blow
I
up,
have
bro.
since forgotten the solution, and it is not fair to ask difficult puzzles, to present difficult puzzles like this in oral form without presenting them on paper and giving people on the train. I dragged Sealion with me against his will onto the train, and now I'm asking you to move on from this point.
All right. I vote we put a poll up to the audience and get on the train.
The isotropy of the speed of light and how it relates to Maxwell's equations, the laws of physics thereof.
Okay. Well, we can use Newton in a bucket if you prefer.
No, let's just stick on this one topic. So if what you're claiming is true.
I argue, like, however, Wolf and Pettit.
Well, there's jumps in this. I wonder if Jaren was having buffering issues.
Noted that the data set they analyzed in the velocity component in the line of sight between the satellite and the ground receiver measured, and then they correct for it.
Well,
and then they correct for the differences.
How is it measured?
Range measurement equation, bro. We went over this from the beginning.
Timing and the range measurement equation. GPS is a timing interval system.
I dispute that this is in this experiment. You're claiming that there's a one-way speed of light measurement that has been made, but all you provide is a calculation that's been done, and you don't familiar with the ECI.
Right? They're invoking an absolute frame here at the center.
So the ECI frame is the inertial non-rotating frame with respect to the stars, often used for spacecraft. The ECI, that doesn't imply an absolute frame in either.
Oh, well, see, this is the whole point of the ECI. It's why it was created in the first place, to give the illusion of that requirement, right? So that's why they converted.
So
that isn't an appeal to authority. That it was
jumping a lot. So for reference, ECI frame and ECEF frame are two things that are used for in different things that people do, especially in ECEF is used sometimes in different things dealing with the entire Earth, right? When you need the whole Earth. So ECEF is a Cartesian coordinate system where 0, 0, 0 is at the center of the Earth. You have an XYZ axis. There's a vertical axis that goes up and down through the rotational axis of the Earth, right? So from the North Pole to the South, North geometric pole to the South geometric pole is the one of the axes, and then you've got one that comes out the Earth at on the 0 line of longitude, and then another that comes out and 0 and the 180s that meet, right? And then the other is at the 90s, and those are Earth-centered, Earth-fixed. So it's fixed to the Earth. So as the Earth rotates, the reference frame rotates with it, right? So you can think of it as I've got my can of tab here, right? And say it's coming out the surface of it right through the middle of the A, right? That's the axis is sticking out the A. And so it rotates with it. So now that it's the axis is pointing out with it. Now, some flatties like to say, well, the fact that the reference frame is non-moving with relation to the surface of the Earth, then it's not moving. Well, no, and that's not what Alan and Shane are claiming, or Shane. That's not their position. They're something else that's not right. But anyway, so that's what ECEF means. Earth-centered ECI, Earth-centered inertial, is what you'd where would be. Let's see. I'll use the here from above, right? This is our stand-in Earth, right? It's rotating, right? But something out here is not rotating, right? So this guy doesn't want to use a reference frame, right? If it's a satellite orbiting the Earth, right? You don't want to use a reference frame that's tied to the surface, because it's not touching it. It's independent of it as it moves, right? So it goes like this, right? It moves. So while, right, well, they could even go opposite directions, right? Like this. You see, if you tied your coordinate system for this guy to the surface here, it would be a little bit confusing, wouldn't it? Right? So you don't My hand's in the way. So you don't want that. So Earth-centered inertial is what this one is, where they're disconnected like that. So I don't know. Hope that helps. What they're talking about. ECEF, fixed to the surface of the Earth. ECI, not fixed to the surface of the Earth. They're like, they just used it for blah, blah. No, they use it like you need it to do a satellite orbiting the Earth because it's not tied to the surface.
That is my opinion.
That's clearly not the case. Now we have Neil Ashby, the guy in 2000 who did it mathematically in things like the ECF frame, or the ECI frame to
show us empirically.
Yeah, that's what I want to say. So I have one equation.
Paper, it took me 3 hours.
Okay, bet. So when you start being pedantic as fuck with me, just remember that you
I am
can't
not
answer a
being
simple
pedantic.
question.
Sealion and I are asking for explain those empirically measured.
Letting you know so you don't run into it. Not seeing it.
All right. I already substantiated it with all
The measurement of the one-way speed of light contradicting relativity within your lab frame.
Well, the time is ticking down quick here. Do you guys remember, did he stop having issues?
Did you not just read where they were making a first that will have effects on the measurement, but what you're trying to assert is
The Maxwell equations. Therefore, your notion that the laws of physics would be everywhere on Earth as a function of this absolute reference frame is also refuted.
It's influenced by the presence of matter and radiation, and it affects how matter and radiation propagate through it. This is empirically measurable. The results of those features of ether are phenomena that we call time dilation and length contraction.
Let me address Adam again here. I'm waiting for your engagement on the words I bring up. Bring up. That's good wording there, buddy. But it's all been hate you and F you and you're stupid. Didn't spell your correctly. No real debating here. When is all the name calling? So Adam, the reason why is because you're just lying. Right? If you want to debate, bring evidence. You could send me an email, mctoon@mctoon.net, and we can have a face-to-face debate on here. We could set it up for next week. You could bring the evidence. Not just word games, right? Masturbating to word games doesn't change the shape of the Earth. Right? When you read airplane and then you just whack one out just because it says plane in the name, that doesn't change the shape. Okay, Adam? That's juvenile. But if you have evidence, and here's the challenge. I know you don't have evidence. And when you're like, should I do that? Oh, I would have to bring evidence. Nope, I'll run away. That's what you'll do, Adam. You'll run away. You have to, because you don't have evidence. I know that you don't. That's flat Earth. That's the essence of flat Earth. Zero evidence is flat Earth. Right? You don't have measurements. You don't have a video or a picture of something that's partially obstructed by the horizon getting zoomed back where now you see all of it. That's never happened once. You have no evidence of that. You just blindly believe that it exists. So when you come in here lying as if you're a religious person, right? Then both religious people and non-religious people see that and are offended at it for different reasons. You are a horrible person for parroting lies. Stop lying. Stop parroting lies. Stop being so gullible. It's part of who you are, though, Adam. You're dumb. Right? Oh, he wants to meet in person. Tell you, sure, absolutely, Adam. You want to meet in person? Right here. Right here. He says, let's meet in person. Adam, 100% I'll do that. We can, I will even book the venue for this debate in person. Email me, mctoon@mctoon.net, and we can set up this in-person debate. I'll book the venue. Won't cost you anything. I mean, you need to get here, right? You need to get here to Minneapolis area. I'll book the venue. We'll meet in person, right? Right. Now, just so you know, I've dealt with this before. Nothing of what you're saying. Nothing of what you're saying is new to me. Not one thing. Here is the Coward's live debate defense list. Right? Right here. So what are the things that cowards use to run away from engaging in a live debate? They block. They say there is no debate. They say someone else already demolished you. They demand a concession in order to debate. They say you're a shill. They say pay me. They say we're already debating in comments. This isn't debating. This isn't debate. Right? A debate is where there's an interaction and your feet can be held to the fire. When you make a claim, somebody else gets to say, that's where we're at. Back up your claim. Right? Here, you're just like, challenge someone that has already said they won't debate this topic. Demand to debate in person at your location is a coward's debate defense. You just said, let's meet in person. I'll be happy to. Right? I mean, who are you, Adam? I don't know. Maybe you are somebody. Maybe you are a well-known flurf using a different YouTube account. I don't know. But it says, unless both debaters are well-known, why would anyone expect to have a debate in person for unknown people? Nobody. Right? An in-person debate, but tell you, I'm good for it. Second part, want to do in person? Offer to do the travel. Otherwise, it's clearly an escape tactic. So, you have said, let's meet in person. I accept. We can debate in person. I will pay my money for the venue at which we can debate. Email me, mctoon@mctoon.net, and we will set it up. All right? Or don't, because you're a coward and you know that you have no evidence. I have zero respect for you, Adam, in case you didn't catch that.
These are empirically measured in numerous ways. You have focused in your arguments on several phenomena that you like the Sagnac effect. You have completely left the time dilation due to gravity unaddressed. Nothing that you talked about addressed that, why a clock at a different altitude runs differently than one below. And as interesting as some of the papers you have shown us may be, they do not form the main body of scientific understanding of these phenomena. And they're not empirically substantiated. You mentioned patents, you mentioned possible devices. You said if they worked, then they would show. Well, they don't work because they don't exist. Therefore, they don't show. Thank you.
Okay.
I think we came back a little bit fixed. Yeah, and I made a mistake in saying that they had only had 50 seconds left, but it was 8 minutes and 50 seconds. So you guys can keep going if you want, or we can are you going to finish up the outros? Is that what we're doing?
Yeah, I think we're doing. Okay. Yeah, we're doing closings.
Sounds good. And I'll check the super chats.
So I think your not thought experiment, but example of a train in motion with lightning striking both the front and the back, which would, detonate the train, really illustrates that it's all fun and games, right? When you're not in the lab frame, when you're making measurements, when you're in the theory of space-time, when you're putting number lines that have no connection to reality and space and manipulating them with space-time equations that actually have metric tensors that covariantly transform things back and forth. But when lives are on the line, when shit matters, it's in the Earth frame and relativity goes out the window. That shit.
Oh my gosh. But I was talking about accountability, right? And this guy right here, he's like, when lives are on the line. None of your crap is about when lives are on the line.
That's the point of the experiment. You guys realized it immediately. You're like, hey, no matter how you're looking at the train, no matter which relativistic frame you want to be in, when it hits, it explodes. There's no two ways about it. That's the whole point. The position, right, refutes relativity in its essence.
Oh, and look at this. Adam says, I tried. Thought maybe we could have a real discussion with evidence and you could bring a camera to record or go live. But I'm just stupid for thinking you might be game. I just said I would do it. Email me, we'll set it up, I'll pay for the venue. Wow. Strange guy.
The fact that it explodes at all means that relativity is dog shit. That's it.
All right.
So if that's the case, I really look forward.
It's closing statements, sir.
Oh, okay, sorry.
Did you have one, or did you already go? I forget.
How much time do we have left, Aaron? Because
a minute to do your closing.
okay. So this is the fundamental thing, right? So you have not been able to answer the fact that we provide a consistent definition of ether based on general and special relativity. We've provided empirical effects thereof. Your only refutation is to invoke the Sagnac effect and this notion of falsification of the relativity of simultaneity. However, if such an absolute lab frame exists, it would be possible to measure the one-way speed of light. You have never provided an experiment that does so, therefore your theory is falsified.
Okay, so everybody got theirs in? Looks like we have a...
I'm about to get mine.
Yours, okay, go.
Oh, all right. So Peter and Lucas finished theirs. Shame and Alan did not. And then there's questions and stuff. I don't need to hear Adams. You don't need to hear Adams. That was pretty good. They certainly did not like some of those things. They had, especially the muon thing, and I brought that up when I debated Alan on this, and he had no answer either. He had the same escape mechanism. We don't know where they came from. That never was the thing. The super chats were all from Witsit. Yeah, don't need to give him any more. Man, his ego. If Witsit's ego were any larger, it would collapse into a black hole. But I got a few of super chats here. I'd much rather hear your super chats than Witsit's super chats. Randomly Epic says flat earthers don't need a scientist to tell them the earth is a globe. They need a psychologist. Or a psychiatrist? I don't quite know. I think psychiatrists. Psychiatrists can prescribe drugs, right? That would be the one they need. Right? Anti something drugs. And maybe a pet itself. The Atheist Hammer is a new member at Newton. Thank you. Randomly Epic gifted 5 memberships. Thank you very much. And if you're the recipient of that, make sure to thank him. Sealion Prime says we entered the Sagnac act of the debate. And now we've exited that. Sealion Prime says, Patrick, your genius is showing. Who's Patrick? Must have been another flatty in the chat here. Sealion Prime for $5 again says, did anyone notice the bait and switch by Alan? First, he argues for a preferred frame. Next, without any additional evidence, he says absolute frame. And that is a drastically different thing in relativity. Yeah, absolute, like there's only one coordinate system. There's a 0, 0, 0 in all of the universe. That's absolute. Randomly Epic says you should use Chuck E. Cheese as the venue. That way, at least you can have pizza when he doesn't show up. Adam says no time, no date, no place. Scared of truth. Okay, absolutely, Adam. Let's do this. This is how stupid you are. Yeah. All right. Let's see. Right here. Let's do Wednesday, October 2nd, Minneapolis, Minnesota area. A specific venue. Well, I can't book the venue at 2 a.m. So I will get back to you on the specific venue, but the debate will begin at 6 p.m. U.S. Central Time in Minneapolis, Minnesota. Now, Adam, I've given you the time, date, location. Okay? I'll get more specific on the location. There's certainly any number of places that I could have. It'll be within the Minneapolis-St. Paul metro area. If you need to fly in, then I will let me know. I'll choose a venue closer to the Minneapolis-St. Paul airport. If you will be driving in, you let me know from which direction you will be driving in, and I will move. I will choose a venue that is closer to the area of the Twin Cities that you are arriving from. For example, if you're coming from the south, then on 35 W35E, maybe Burnsville or Farmington area would be good. If you're coming from the east, we could have it in on the east side of the Twin Cities. Maybe I tell you what, we could even do it in Hudson, Wisconsin. If you're coming from the east, if you're coming from the north, from Duluth, we could have it up north there in Pine City. If you're coming from the northwest, from like the St. Cloud area, then I'll pick a place in Rogers. And if you're coming from the west, then I'll pick a place like in Minnetrista. I love Minnetrista. It's a fun place. It's a tiny little. Belle Plaine, maybe, not Belle Plaine. St. Bonifacius. Right? You let me know. And I'll get it set up. All right. Now, Adam, I have given you the time, date, location. Email me mctoon@mctoon.net, and I will continue with this, and we'll have it'll be a great debate. We'll live stream it. It'll be fantastic. You are on the line to bring evidence for your claims. Now you'll be. How about St. Louis? No. I'm not driving to St. Louis. You want to do it in person, you come to me. So if you want to do it in St. Louis Park is a suburb. I'll do that. That's somewhat, it's not super convenient to the Minneapolis-St. Paul airport. It's an inside the loop suburb. I don't know if, it's not really convenient for you, but if you are in St. Louis, then you would be coming from the south. So yes, that would be Burnsville or Farmington. One of those, somewhere in that area. Apple Valley, right? Inver Grove Heights would be very convenient for me. No, Mark Sargent is not going to be. Mark Sargent's a chicken. Yeah, St. Louis is not in Minnesota. No, it's not at all. So there you go. You said, Adam, you said no. What was it? No time, date. Hold on. He said time, date, place. You asked me right here. You asked me time, date, place. I specified time, date, place. Time, 6 p.m. Central Time. Date, October 2nd. Place, Minneapolis, Minnesota metro area. And I will customize it based on your convenience. There you go. Name 2 things that would make you happier than watching a sun circle above Whitset's head in December. I'll have to get back to you on that. Yeah, it's a debate, right? This isn't a hookup. I'm not into you, Adam. Not into you. So, all right. And are you running away now? I can't afford to drive all the way. Meet me means meet me. You asked for the place. I gave you the place. It will cost you 0 gas dollars to have a live debate on YouTube. It's very obvious. It's very, very obvious. This is, right here. This is Coward's live debate defense. Right there. Why would I have to come to you? Why would I put in any effort to come to you, the idiot in this situation, the unknown person who has no idea that you're just parroting tropes from 9 years ago, right? He also said he didn't need your money, but now he can't afford it. Yeah. So I have two $10,000 challenges. They're on pause right now. But you know what? Just for you, let me know. If you come up with a solution to one of those two, one of the two challenges, I will honor just for you. And what are they? I will gladly tell you what they are. Let me show you the first one. And then the second one. So here's the first one. The sextant challenge, $10,000. All you need to do is use a sextant. The measurements taken from a sextant, here they are, to determine where the observer was. But you can only use a flat Earth, right? So that, right, this $10,000 could then pay for your gas money. The second one is a gravity challenge. All you need to do is use whatever you think is the cause of the downward acceleration to predict the magnitude of the downward acceleration for different areas on the surface of the Earth. It varies slightly. And the variations are predicted accurately by the globe. So there you go. There are the two. There's your $10,000. You could make 20 doing that. Anyway. And this, in real time, we've been shown that Adam's a chicken. So, Brilliant says Adam's too inept. He needs you, Toon, to help him do experiments, and he holds his hands when he crosses the road. I have two things left. Number one, I'll remind you all. You know, I'm going to Antarctica. Planning to go to Antarctica. It's kind of expensive. I'm crowdfunding to do it. While this was happening, CJ Lamoureux sent me one on Cash App, a decent sized little boost there to help. Thank you very much, CJ Lamoureux. I appreciate that. I'll do a live stream, invite people on maybe next week to talk about the trip and get some ideas and some feedback from you. I will. A lot of people have already committed money. So grateful. I mean, it's been very amazing. It's not yet been a week and I'm over 8,000 total. That has been provided through crowdfunding. It's just amazing. So, anyway, the link to the crowdfunding is in the description of the video here. I really appreciate it. Number two, this one's a little more serious. Arctic Reflections, a channel does some good stuff, but made a foolish bet. Let me see if I have just a second. I'll make sure I'm getting some things right on this. Nope, not it. There it is. Okay. So Arctic, yeah, it's Arctic Reflections. I'll put a link to a video here from him right there. So Arctic Reflections bet Jaren about whether or not the Deer Moon trip would happen in 2024. The year is 2024. It has not happened. It's September. But months ago, the project was canceled. It's not going to happen in the year of 2024. Arctic Reflections cannot win the bet. Right? I'm very much not in favor of challenges or bets where the money is not in escrow, because this can happen, and it happens on both sides, right? I've never seen a flatty pay up. I've seen Globers pay up. I've seen Globers not pay up because they did junk challenges. So I have 2 challenges. I put a lot of effort into outlining them and having fair, objectively measurable acceptance criteria. The money's in escrow. Somebody else holds the money. The challenge can be judged by independent third parties. So it's all out of my control. I can't say, no, I don't like it, and then not pay, right? So when you do a bet, you got to pay if you lose. So Arctic Reflections, you have lost. The mission was canceled. So saying it was for the year 2024, and the year 2024 hasn't yet ended. I get that. You're right. It didn't end yet. You want to play a semantics game? Then, yeah. The year isn't done. But it can't happen. It's not possible for it to happen. So I would say Arctic Reflections, do, meet your commitment, right? You made a commitment and do it. It was a foolish bet. Betting on whether or not a large project will happen or not is it's not smart. Especially if it's reliant on government things somehow, right? So SpaceX in August was ready to do flight number 5 of Starship. Currently, they're still waiting. The current, to my knowledge, earliest is November for the next test of Starship. Not because of SpaceX, but because they're reliant on the government to give them a license to do the test, right? Betting on something that involves the government doing things in a timely manner, you're never going to win. Anyway, that's my message to you, Arctic Reflections. I would just say, you bet them, do it. So, anyway, one more from Adam. Look at this. Oh, Adam, he says, no need to go to Antarctica. I know there's no 24-hour sun. Well, tell you what, Adam. Tell you what. If that's the case, if you actually are confident, right, then you would be confident in putting money on it, right? If you are confident in your position, here's your chance right here. You can. This is done by Flat Earther, by the way. This flat stationary right here. This is a bet on BetMoose. BetMoose is an independent third party. You put the money in, they hold the money, and then they pay out the winner. This is the type of thing I like, because the money is not in your hands. So I have put money on this, not much, because there's not much on the other side. I've put 0.02 and 0.0069, so 0.0269 Bitcoin into it. It's like $1,700, I think. Is that right? Anyway, some decent money. I have more to put on it, Adam. So you could come here, right here. I'll put in the chat here. And if you know the truth, then you could be the one to take the money here, right? If you wanted to bet, no, the sun will set, right? And you put the 0.2 up there, the payout would be 0.04377, right? You'd more than double your money, right? And here's what I'll do. If you put 0.2 in there, I will put 0.2 in there. I haven't put it in there because nobody else has. There's very little flatties in there, right? You could make more, and I'll match whatever you put in there. I'll put in the same. And so this is just if the sun circles overhead, I win, and if the sun sets, you win. So Adam, if you know, do this. If you don't know, you run. So, and this, I mean, this really, this here illustrates perfectly. Who put money in? 0.0001, the super brave flat earther that hosted it. And then the other person is Where's Wally, who accidentally put it on the wrong one. So far, one flatty and all the rest are from Globers, except for the accident from Where's Wally. Anyway, there you go. What do you think? Go ahead. Adam said he doesn't believe the Earth is flat. What? Where'd he say that, Icy Spin? Oh, you don't gamble. No, it's not a gamble, though. Because you said you know that it won't do circles. That's not a gamble. Right? A gamble would be betting on something that's random. This isn't a gamble. This is about reality. And you say reality says, in reality, the sun will set. You said it in, your claim is, in reality, it's 24 hours. You see? You see? It isn't a gamble to you. Because you know. Right? You know. That's what happens. No. Adam isn't the brightest bulb in the pack. Adam isn't even a light bulb. And he's trying to be a light bulb. So anyway, there it is. A gamble is a bet. But this isn't a bet just because the website says bet moose. Right? Here's a bet. There's other things that are bets on here, right? Here's one. You don't know. Right. Who will be the winner of the presidential election? I don't have it on screen. There you go. Don't know. Don't know yet. Right? Some people have some, confidence about it. Most of these tend to be on politics. There's some no sports, some on economy, lots on politics, some on Bitcoin. Will Bitcoin reach a certain amount by a certain date? That's a bet because you don't know, right? You might have an idea. Will GameStop hit $50 by the end of 2024? That's a bet. I don't know what that is. So another bet would be, if I throw this pair of dice, will the number be this or this? That's a bet because it's random. So yeah, don't pray for us, Adam. Don't pray for us because you pray to the dark one. We don't want you to pray to that guy for us. Yeah. Poly market is one too. All right. Anyway, people, thank you very much for joining me. Thank you to Lucas and Peter for the excellent debate. Next Tuesday, I'm at Megadeth. I will not be doing a live stream next Tuesday. I have Wednesday, Thursday, maybe another one next week too. We'll see. If we got some, I got a lot to do. I got a bunch of streams to cover here. The Wednesday one will be with FTFE on this channel. And then Tuesday, not certain yet, but it'll be another late night one. I like these late night ones. So I get tired, but I'm a night owl. So, all right, let me get the outro. Okay, people. Mahalo for all the streams, says Lisa. Oh, and Lisa, next week I get to place the order for the big drive bay, big USB drive bay, and then I get to put in right here that drive, these two drives. So anyway, people, thanks a lot for coming along, and we'll see you next time. Here we go.
MC2, drop that beat.
All right. Let it flow. Let yourself go. So I know that is the tempo.
So, yeah, let's do this. So,
Let's do this. Yo, it's MC2, the debunking tycoon. I shatter flat earthers, make them face the moon. Your attempts are decent, but they'll swoon in the face of my logic like a deflated balloon.
Oh, MC2, the monsoon cartoons. On the real stage, send it first to their views. Your theories are like old brews, sweeping ignorance or just spreading the views.
FDFE stands for fumbling the facts, evidently. I drop truth bombs so splendidly. Your approach is soft, mine's unrelenting. I bring the science while you're just venting.
MC2, the thing with silver spoons. I have some pseudoscience, make them change their tune. You're the sidekick, I'm the rude. When it comes to debunking, I'm the rude.
But hey, FDFE, we share the creed to educate and debunk the plant the seed. Though in this rap, it's clear indeed I've got the upper hand in word and deed. Alright, hold on a second. The Zoom call died. Everything died! No!